So instead of wasting any time, directly I'm going to the today's first stuff. So that is GIS database creation. Let me go into the presentation mode first. Hope my screen is visible to everyone.
Yes, sir.
Okay.
Yes, sir. It is visible, sir.
Yeah, thank you. So in the session, we'll see how we input the data. I mean, anything is coming to the GIS, it's not direct. There are some procedures how we take the data in the GIS. Then you cannot take anything raw as it is garbage. So we need to follow some of the standard. And for that standard, there are some concept we call that is topological concept. We see what are these standards and what is the topological concept, why it is important. So one by one we'll see this. Then as you know, in GIS, the maps which we see on the screen, they are always attached with some attribute data, attributes to that map, to that maps, right? So these attributes and the map, these are basically the separate entities integrated together in the GIS. You might have seen the attribute tables while working on the files. So we will see how we can link these two data sets together, and some quality related aspects of the GIS data. So like any activity you plan to conduct that activity, similarly here also while creating any database. So now in GIS, uh, when you say the data or database, basically there are two things. One thing is that you will get something ready-made data. For example, you procure or download the satellite data, or maybe sometimes you are downloading the vectors from the open street. So these are the ready-made datas which you bring into the GIS. Either you procure it from someone or you download from the available web sources, and you take that this data into the GIS. So in this case, you required a little editing, little adjustment based on our project requirement. So basically we plan from where to get the data, what type of data, whether it is raw data, whether it is finished data, and you plan that activity, and then you enter the data into the GIS. So that entering the data will be right from importing the data, which is available, readily available somewhere. Then another is uh, you create your own data. I mean maybe from some existing data available. For example, I'll give just example. You might be knowing the topographical maps or the road maps available, or any maps which are in the hard copy, I mean in a paper format. So you take that map and you convert that into the digital database of GIS. So series of steps are involved. Then you edit that data, and after all, when it comes to the GIS, so data must be projected. So we'll see the georeferencing later on in this session only. But the projected data or georeference data means that the maps which you are creating, the data which you are creating, it is having the projection parameters. It is georeference data. That means, like, when you overlay or project that data, the data will fit on the Earth's surface to its respective position on the ground. Okay, so that is meant by the georeferencing or projecting the data. Then at the same time, uh, sometime data is available into the different format. Maybe data is available into the raster format, but your requirement is vector format. So you can convert on the fly vector to raster, raster to vector, or you can change the file format, pics, there are various file formats, so you can change from one format to another format. And once the data is ready with all the respect, then you construct your database, maybe in personal geodatabase or in any other formats, which is ready to be used, ready for the analysis to retrieve the required information. And finally, you link both spatial and non-spatial data together so that both can be used in the analysis or output. So these are the broad steps for every GIS project, for every database we use to follow for encoding into the GIS. Okay, so let me ask you a question. Uh, can anybody tell me what do you mean by analog and digital? Very broad difference, broad understanding about the analog and digital. Just switch on your microphone and quickly let me know what is your understanding. I know everyone knows this, but just I want to orient you on a right term. Yes.
Hello. Hello.
Oh, okay, no issue. See, you know digital clocks, everyone.
Hello.
So it's difference between their electric signals,
Hello.
amplitude.
Hello.
Okay, Vishal. Actually, this is very broad term, analog and digital. You will find this in database, you will find it electronics, you will find it in signaling also. So, analog and digital is a commonly used in many of the technologies. Okay,
Sir,
so
is it like
broadly,
continuous and discrete? Like in analog, the inputs
ex
are continuous and
exactly. That is the exact definition of analog and digital. So anything analog is a continuous data. Anything digital is a discrete or discrete data. So basically, you just bring the digital clock and analog clock. The clock which is having three hands, that is analog, which is continuously moving, and digital um, intermittently it is giving you the readings. So that is the difference. But here what I emphasize in case of GIS, analog you just consider all the maps which you see in the paper formats, and digital maybe all the maps you see on your screen or in a digital format. So whenever the term comes analog, so that may be something related to paper formats, and digital something related to digital data. So now we'll see the data sources, so and how they are important and what are the precautions we should take. Let me, acha, I have to admit, admit all. Okay, fine. So when we say the data is the one of the most, I can say the most component in the GIS. Why I am saying the most? Because if the data is not correct, if the data is having any error, so whatever software you are using, so no doubt whatever competency you are having in analysis, the results will not be perfect. Okay, so this, if you are making something and if your raw material is not proper, so the finished product will be accordingly, it will not be proper or it will not be up to the mark. Okay, so the data is the most important part of your GIS project. As good as data is error free, there is possibility that you will get a good output, provided that you followed the proper way. Okay, so the data is the most important part. So now the capturing data, that is, this operation is important, more important than writing the data into the your database. So capture the right data is most important, and then you write the that data or store that data at a particular location or in a particular database where you desire to store it. So please be remember, whenever you work in any of the GIS project, so the most focus should go on the data. Okay, so data is the most important part, and it's most essential also. Without data, whatever software we are having, whatever our technical capability is having, we cannot do anything. So data is most important part, it's essential part, as well as, though I can say there are many database nowadays available even in open source also, freely you can get the data, but the right data, error-free data or data appropriate to the project, many times it becomes expensive. So it is a expensive also. And another thing, it's a time consuming activity. See, creating a data of, say, for example, a district, it may take 2-3 months, but further analysis you can do in one day or maybe in 1 hour also. So data creation is a time consuming activity, right? Let me reduce background light little bit if I can. Otherwise light is coming. Just hold for a minute. Okay, so I don't know how, where is the background, but I think now light is okay. Lobby, admit all. Yeah. So now, when you think about the capturing the data in GIS, sometimes you feel overwhelmed or confusing, because why I'm saying, because there are different formats available for the datas. Then there are different sources requesting to record this meeting locally. Uh,
Sir, you may deny the permit.
yeah, yes.
You may deny.
So it will be recorded on my system now, I think.
No, you may deny the permit. Somebody is trying to record in their system. So just because you're already recording in the
Okay,
cloud, better you deny the permit.
okay. Anyway, so it may be confusing. I mean, this activity may be sometime confusing, so we have to take the wise decision which data, where you will get, is the data is useful, is the data is authenticated. So these questions we have to ask to ourselves, and then we can go for the selection, right? So before taking any data, you have to evaluate it. You have to evaluate for its authenticity. You have to evaluate whether the data is right for you or not. As I told earlier, data is the most essential, most important component of any GIS project. Now, when we are capturing the data in the GIS, so there, as we discussed earlier, there are two components of the data. Please remember, in GIS, there we'll see further details. there are two components. One is the spatial data. As I told earlier, spatial data is nothing but the maps which we see, as simple as that. And the attribute data or non-spatial data, so that is the tabular data or attributes which your either line, point or polygon is having. For example, location of point. See, you are putting village location. So location of that village on the map, that point dot, that is your spatial data. And the name of the village which coming as a text, that is your non-spatial or attribute data. So these two data we are capturing and further we are linking together. Okay. So when you do this activity in the GIS, and this is the graphical representation. For example, here you can see, let me put this one. Pointer. Pointer option. Let me put some pointer here. Yeah, this red color is the pointer now. See, for example, this type of data you see on your screen for any map, and then you change these are the ABC or 1 2 3 numerics. These are the attributes. So these attributes are coming from your non-spatial data, and these lines, they are coming from your spatial data. Okay, when I'm saying the linking these two, so how this data is linked? For example, this polygon named with A will be having arcs or lines, you can say. So this is line number 1, line number 2, line number 3, and line number 7. With these lines joining together, it forms a polygon. But in attribute, they are, or in non-spatial data, they are having certain nomenclature, and we are joining this table with this spatial data. So this joining is nothing but the linking, right? If you have any doubt or any difficulty in understanding, let me know. Okay, don't wait till end, we can discuss there itself and finish. Now I think we had some discussion on the GIS data or geographical data. So what I hope now you are had understanding that GIS data is having some maps, some non-spatial or attribute data, and they are linked together, right? So this understanding we are having, these are the components for any of the GIS data, right? So whatever the file format is there, but this will be the format, this will be the understanding, and in each GIS data you will find this spatial data and non-spatial data, right? So now what do we mean by geographical data? That we understand its components. Now further little detail about the geographical data or GIS data, like many times we heard that spatial data, non-spatial data, spatial data, non-spatial data. So in spatial data, again, in spatial data, now we understand what is spatial data, what is non-spatial data. Now in spatial data, again, there are two formats commonly used. So what are these two formats? One is vector and another is raster format. Now let me first take you to the raster format. So anyone is having any idea how is the format, raster format? I know you know the example. If I ask the example, you will say photo, you will say satellite data. But how exactly the raster data is? How it is arranged? Anyone can give me deep insight little bit on raster data, your understanding on the raster data? Don't be
Sir,
shy.
it
Let
is
it
in
be the
pixel
blunder
format.
answer. I will more appreciate blunder answers rather than correct one.
Sir, it is in pixel format.
Exactly, pixel format. Yeah,
The raster data can be in different format, like uh, as in this slide it is mentioned, it is also part of the spatial data. But in the spatial data, then only can be happen. Suppose there is some georeferenced image and some satellite image that having the all the projection system and the coordinate system, it is completely coming on the right area. So that is the raster data also. And the second thing is the raster data. Suppose we have some TIFF, some JPG, and some details of the particular surface is there, but that is not a georeference data, that we can add that raster data as in non-spatial data also.
Right, Kamal. But my question. These are the different data types and the parameters associated with raster data. I am asking, what is your understanding about the raster data? Any format, either it's a TIFF or PIX or anything. Like one answer I got from Vishal is it is having pixels. Exactly fine. So now how these pixels are looking? I mean, if in a raster data, if you lay down or if you want to draw the raster data with the hand, for example, so how it will look like?
It is looking like as
The
pixels
draw
only,
Raster
because
data,
raster data stored in pixels
One by
only.
one, please, one by one. Yes,
sir,
yes.
raster data can be an aerial photograph or a satellite image.
No, can you draw aerial photograph or satellite image as a raster
No,
data?
no, sir.
But if you want to draw it, how you will draw?
A grid form, like rows and columns.
Exactly, exactly. And that is, I was expecting the answer. So the most and important part, whatever type or whatever that file type, no matter, but all the raster datas will be having in grid form. Please remember this grid form. Now, if anyone is having difficulty in understanding what is this grid form, so it's just like a table, just like a table you draw with your hand, or in Excel or in Word you draw the table, na? Which is having rows and columns. So your raster data will be exactly same, which will be having rows and columns. So grid format, which will be having, as Vishal told initially, is pixel. It's pixel. So each grid is your one pixel. So that is exactly the raster data. Please don't forget for any time. Remember personally, permanently, raster data is nothing but the grids. That's it. Whatever the file format, it will be in grid. There is no other option that raster data can be stored, right? So this is the raster data. Then types. Raster data can be your scanned image. Raster data can be your satellite data, IRSP6, LIS3, Cartosat, AWIPS, any data, all are raster data. Satellite data are raster data, scanned images are your raster data, photographs which you click, that is also nothing but the raster data. So in the spatial data, one category is raster data, another category is a vector. Vector means, like, you might be drawing some boundaries, digitizing something, all these are the vector data. So in vector data, what are the possibilities of having the data? You will be having point. Remember, sometime you put the point in a layer, or while digitizing some locations you put the point. Another possibility is line, or you can say arc. So point, line, and one more is polygons. You commonly draw the polygons for encircling any area, that is polygon or area. So these are the three types of the vector data: point, line, polygon. And another special type of data is a raster data. Clear, everyone?
Right, sir.
Yeah, if anyone is having slightest doubt, please raise your hand, open your microphone, and ask the question. If you this is because why I am emphasizing this. This is the base of understanding the data. If you fail to understand vector raster, then it will be difficult to understand further stuff on it. Okay, so let me know if you have any confusion. There are three types in vector: point, line, polygon, and another special data is raster data, which is in grid form. Because understanding this is very important. Why I am saying this? Because if you draw line in vector and if you draw line through the raster, there is vast difference, because the advantage and disadvantage again varies with the type of data. If you draw line with the in a vector data, it will take very small area, width will be very small, precisely you can put a line. But if you want to depict the line through the raster data, that depends on the width of your pixel or width of your each the grid. If it is 10-meter grid, if you have taken in raster, so your line will be 10-meter width. Okay, so this will not be case in the vector line will be very thin, maybe 1 meter, 2 meter or less than that, or even in centimeters also. So choice of the data while using or inputting or creating the database, that depends. That's why this understanding is very important. I hope spatial data, you have certain understanding now. You have certain confidence, so you can easily make a choice which whether I have to use raster or I have to use vector. Okay, and on the fly you can always convert vector into raster, raster into vector. But when you are drawing the roads and you draw in a raster data, if you convert into the vector, so it will be difficult to change the exact width, so width will be more. So that choice is important, and for that choice our understanding on the spatial data is equally important. Now coming to the attribute or non-spatial data, which will be linked with the spatial data, that
Sir,
that
hello.
is nothing but the tables. Divanshu, you want to say something?
Yeah, hello, sir. I have one question.
Yes, yes, please.
So, like, if we take data, like, collect the image from a drone,
Hmm.
so that will be considered as a satellite data or scanned image, raster data, or something else.
See, definitely that image that which is coming from the drone. Drone is having camera, and camera is capturing the data that will be in grid form, and that is the image only. That is image. That is raster data.
So basically, raster
So
data, right?
yes. So the satellite data is also raster data because it is captured by the satellite. So we call it satellite data. Okay, like for drones, we say it's a drone images, but in a technical way, both are the remote sensing data. If you see the definition of remote sensing, without touching,
Oh,
coming into the physical contact, you are
okay,
capturing the
okay,
data.
okay. Both satellite data and drone data, scanned image, both are raster data, correct?
Exactly, both are
Okay,
anything is having grid format, that is आग बंद करके राष्ट्र डाटा और कोई सेकंड थॉट आएगा नहीं,
okay, sir.
right?
Thank you so much.
Yeah, and now the non-spatial data is basically your tables, your text material, text or numerics, whatever you want to write village name, you want to write want to give some numeric codes, everything will be coming into the non-spatial data. So I will suggest each one of you, maybe when you find some time, okay, maybe after this class or when you have any leisure time, you just open your file in GIS. Now, if you open in a file in your GIS, it will bring spatial data, non-spatial data all together, and you will not able to see the files associated. So what exercise you will do, you open your GIS file. For example, you might be having some file with extension .shp or .pix or .tiff, any file you open. For example, you open .shp file. So where you have to view this file, you have to view in Windows Explorer, not in QGIS or GIS software. There also you can see, but easiest way I will suggest you open in Windows Explorer, and when you open this file in Windows Explorer, you will see at least 7-8 files. There will be .pat file, .aux file, so there will be different files. So One file is for the attribute, that is non-spatial data. One file you will find if you are opening a .shp file, then you will find shp file. So all these single files, 7-8 files together form your single .shp file, right? So all are associated files there, and that's why that spatial, the non-spatial data is linked with your spatial data. Even you can see, you can find one projection .prg, extension .prg file will be there, that is related to your georeferencing projections. So single file will be having 6, 7 or 8 files depending on the version and type of software and type of file in GIS. So please do this exercise, so you will find all associated files with a single file, right? So spatial data and non-spatial data. So this the basic database, basic types of data are very important. Please remember it, understand it, and make yourself comfortable in understanding the type of data. Okay. So when we are capturing the data, now easiest way is we will be having some external data. I will go to the Google and I will download certain data. Fine. If it suits our requirement, yes, we can use the some available data. Even nowadays, you can link your spatial data in your system or server. You can link that data with available data source anywhere on the cloud or any web servers. So that is also possible, and softwares are also providing this facility. So you will be having only spatial data with you. For example, you will be having village layer with you, and you can link that village layer with the Census of India village codes. So only you have to create the spatial data. You have to link with the source, external source like Census of India, and you can get the both spatial and non-spatial data. So that is also possible. So you can use the external data, you can link your data with the external data. Okay. But now if the data is not available anywhere, you are creating something different, your project is having different, then you have to create your own data. Okay. So I will now change my gear. I want everyone to understand the vector raster concept. So I will increase little speed. If you have any doubt, you can just speak out. Okay. Now if the data is not available, we have to create our own data. Okay. So how we will create our own data? We can use maybe the data if it is available in some paper formats. For example, soil map in paper form, or land use land cover map, or maybe Survey of India topographical map, geological maps, any map it is available in paper format. So we can scan that maps and we can create, digitize and create our own data. If that is also not possible, this data is not available. So what you will do, you will go to the field with the required equipments, GPS, paper maps, measuring tapes, etc. You can go to the field and you can create your map. You can create your own data. You can create your own data sets, and then you can put that into the GIS. So through the survey method. One is through the existing available hard copy maps. Another is through the survey method. So depending on the project. So data is available either in paper maps, as I told. Then you can scan it, or sometime data you can get in scan map format. So you can go for the digitization, and then you can link the your spatial data with the attribute data. If data is not available, there is no option. We have to follow some of these steps to create your own data. So there are different existing data formats available for the non-spatial data, like right from the Excel to Oracle files, SQL files, so ASCII files, Many formats are available, and always you can change formats as per your requirement. So this is the attribute data table which you can see. Yes, Ajay. Yeah.
Yes, sir. One question.
Yes, please.
Sir, can we create vector data without scanning of the image? At present, any technology is available?
Yeah, you can create vector data without scanning the image. Yes, that's why I am telling you, if nothing is available, you will go to the field and you will capture the GPS points, or you can map itself on the field using the tape or chains, and you can create your own data.
No, sir. Some technology available like machine learning and AI, artificial intelligence. Is that possible to create the vector data in present
No, but
scenario?
yeah, I mean, you can use the technology, but there should be some base. I mean, if you are measuring, for example, I'm giving, if you are measuring the electricity poles,
Right.
okay,
Okay.
and nothing is available, even satellite data is not available, nothing is available. So finally, you have to go to the each pole and you have to take its coordinates.
Right. Survey for.
Yeah, but if you are saying these technologies are available, for example, mm, artificial intelligence and machine learning and deep learning,
Yeah.
this technology, but
Yes,
you
sir.
require some base. For example, base can be your satellite data,
Right.
where and objective is to map the trees, so you know the tree will give throughout green cover, so you can
Right.
use 3 4 satellite data, and this technology can pick up that pixels where it is
Sir,
getting throughout the year NDVI.
Okay, sir.
hello, sir.
Yeah. And people are
I have,
using this
I
like
have one doubt. Can
Sir,
you
present
come
में
again
the
the last part what you said?
yes.
Hello. Can you come again the last part what you said? How to use that machine learning and deep learning here?
Okay, see, basically machine learning, deep learning, these techniques, what we do, these are the algorithms, nothing but the algorithms, and we train the system, like say for example, you have 5 satellite datas, and you in each of the 5, if you get the good NDVI, for example, or good green cover, you can say simply, in all 5, then you will teach the algorithm that this is a tree. If out of 5, if you get only in 2 time data good NDVI or good green cover, you will treat your algorithm, no, it's not tree, it's crop, right?
right, sir.
So in this way, all these AI based
So,
techniques, machine learning, you have to train it
okay.
first,
So basically,
then you can use it.
okay.
Okay.
So this data can be extracted only from satellite image, not for JPEG or TIFF.
No, there are many ways. Like I can tell you, there are companies which are using, like I can give you example now. For example, you are swiping your cards or mobiles for paying something. Okay,
Okay.
so
Okay.
that data is somewhere record, like X, Y, Z, in a month, 2 times visit mall, 5 times visit hotel, 3 times visit petrol card. So your mobile is GPS enabled mobile. So all these location can be tracked at server, and from that GPS locations, you know, if you are going to the petrol pump, that means definitely you are filling the petrol.
Right.
So from that data, we can create a vector and saying that, okay, XYZ is filling petrol 2 times, 3 times in a month at so and so petrol pump. So that can become your vector data. That,
Right.
yeah.
Thank you, sir.
So these are the source. There are many sources of the available data, like hydrological data, soil data, land use land cover data, topographical maps, even satellite data. NATMO is also providing. Survey of India is also providing. NBSS LUP is also providing data. ISRO, NRSC, Bhuvan. So there are many sources where you will get the readily available data. So this is some of the list only, not complete list. Okay. Someone is lobby. Let me admit. Yeah. Now, moving ahead. Now, if we are not getting data, now we are discussing how to create the data. So first, if you are having data, still sometimes you need to create your data because the existing data may not be relevant to our problem. So if you have some data available, but that data may not be that much fine, may not be that much refined to use in your project. So you will create your own data. Sometimes data is old. Say someone has created data in 1970 and 80, so that may not be relevant. So again, you have to create your own data. Another condition when you require to create the data is available. Maybe for example, on somewhere in the US, freely available data is there, but you don't know who has created, what is the authenticity, what is the quality of the data. So in that case also we cannot trust, we have to create the data. Okay, now you have decided to create the data, then how you will enter the spatial data. We'll see the spatial data, how you will enter. So one thing is you can enter the data into the grids, like we discussed grid for raster. So you will be having grids, so you will enter the data into the grids. So interval will be fixed like 10 by 10 meter, 5 by 5 meter. So you will enter the data in each grid manually. Then another option is you will take your mouse and you can digitize on some paper maps or scanned maps, okay, through the digitization process. Or you can take your GPS or DGPS type of the devices, you go to the field, you collect the points. Points is nothing but the lat long information, and you create your own data. Sometimes now some of the softwares, they are providing the voice entry options also. Instead of typing and digitizing through the mouse and devices, you can just spell out, so the data will be created. I hope, I don't know, but I'm sure some of you might be using the voice facility in MS Office and PowerPoint to create the text. Okay, just you switch on the microphone, select your language and accent, and you just go on speaking, so the computer or MS Office will type that text for you. So similar way in GIS also you can use the voice entry and you can create the data. Then if you are having some of the maps, so automatically you can scan it, and based on the color contrast you can convert it into the vectors, lines, points and polygon. And already available raster data like satellite data, you can take that data which is already available and you can create your own data out of it. So these are the examples of special data available in the raster format. You know, the satellite data, various type of satellite data, scanners. So the data already we discussed is in rows and columns, or you can see in the pixel formats. Similarly, nowadays using the aerial photography is less, but still you will get some data in the form of aerial photographs. Then on top of this data, you use this data as a base and you use various classification techniques, supervised, unsupervised, maximum likelihood. So you might have some practicals on it, So you using this data, you create your own data. For example, from the satellite data, you created land use land cover map. From the satellite data, you created your water body maps. So you can create your own data. So there are various formats of the data available, and always I told you, you can convert in from one format to another format. For example, .ssv you can create in ArcInfo format or PIX format or a CAD format also. So you can always create the change the formats. You can import, export the data, or you can use certain statistical and mathematical techniques on the existing data, and you can create your own data or desired data or required data. Okay, so these are the some of the examples I will just run through. This is the what you were discussing about the satellite data. This is orthophoto. Orthophoto means you will be having height information along with x and y coordinates. You will be having z also. So this is orthophoto, where you can, this is basically 3D image, so you will get the height difference. So this way you can digitize and extract the information from the photo or satellite data. So yellow color and red color lines, which we have digitized to get the information from the satellite data. So this is the example, red color lines. You draw the information from the this aerial photograph, and now you are giving some attributes, and then it can be used for further analysis or drawing the information. Now, in case of the raster data, so and its input, how you will create. So every immediate picture in our mind comes like we'll be having satellite data. Okay, fine. That is one of the best available source from satellite data. You can take that as an one of the input to create your data. So from the satellite data, you can create different types of information, different type of data bits in a digital format. So sometimes either satellite data, if it is hard copy, or any other map in analog format, I mean analog mean hard copy format, you can scan it to make it digital. Scan it, the scanning is and you can convert into the usable data. So when you scan anything, so data will come into the binary form. I mean, binary form means the where you have information, it will be having 1 in a pixel attribute, and when there is no information, it will be 0. So basically, it depends on the brightness and color contrast. You will get these binary files, and which further you can use to generate your data. So I am not going to go deep into the scanners. It is available in the text. You just go through. I know everyone knows the scanner. We are using the scanner nowadays. Everyone is using Google scanners for paying and all. So scanner is basically the small to big device, depends on the need. So it scan the maps, hard copy maps, and that converts into the your raster formats. So scanning is always directly into the raster format. So there are various type of scanners like flat or rotating or continuous field large scanners are also there. Now I'll put some time here. When you scan any data, so there is always issues related to quality of the scanning. So for example, most of the scanning operations are done for the paper maps, and you know, the for example, if a particular map is created 20-30 years back, then there will be sinking in the paper, there will be some decoloration, or there will be some wrinkles on the map. So these wrinkles, this decoloring, plus while scanning the movement of the paper, sometimes it may not be straight. So all these will create the quality issue in the scanned image. Okay, so if there is some coloring problem, so you need to perform the despeckling so that you can adjust little bit. Then sometimes you go for the grayscaling, that is converting color into black and white. So because sometimes your grayscales will give you better contrast and better um, visibility or contrast to interpret the data. You will always adjust brightness and contrast so that the features, target features, will be easily available. Similarly, you do the thresholding, like uh, thresholding from 0 to 255, so that you can adjust your image for its more better visibility. So some of these operations we have to do to improve the quality, to reduce the errors from the scanned image. So I don't think anyone of you are using these techniques nowadays. These are little older one, where people used to have tabletop digitizers, where they put the hard copy paper map on this type of tabletop digitizers. They fix here, and with the mouse they used to scan these features on this map. So in case of this scanning feature, like stability is more important. So digitizer should give yeah, it was disconnected for a moment. Let me switch off my video and share the screen. Uh, this is not allowing me to share the screen. Yeah, now I'm the host. Okay. My screen is visible. Can you confirm?
No, sir.
Okay, wait. Let me. Hope it is visible.
Yes, sir.
Okay. Uh, okay, recording is on. No problem. Yeah. So we were discussing that the digitizer should be stable, very stable. It should not change with rise or drop in temperature, and it should provide the same precision and results. Okay. Similarly, it should give the fixed distance as we move the cursor, so the distance should be fixed. So if it is not giving the right distance, then there will be difficulty in creating the features. Similarly, the resolution, the minimum separable distance, like two features, you should easily able to separate. So it should have the good resolution. Similarly, there should not be any skews. If skews are there, your map will not be proper. So these are the some of the important features or properties when you uh, go for the scanning and digitization. Okay. Now, I hope all of you might have done digitization during your projects, right? Or
Yes, sir.
practicals. You did it. Okay. So you did it practically. So digitization is a process actually. In that process, what you do, you are just converting features which are at the background or on the map into the digital format, right? So that is the process. You click means you click through the mouse. That means you are putting point there. That is point. The clicking is you are putting point. Okay, so in that way you do the digitization. So when you put the point, actually what you do, what software is doing, software is putting its x y values. That means lat and longitude information, coordinates it is putting there. Okay, so your each point, when you click, when you digitize, each point is nothing but what? Lat long information. You are just capturing the lat long information or coordinates of that particular point. That is your point. Point is nothing but your coordinates only. Okay, you are registering the coordinates values for that particular point. So that is the your point. And whatever you are giving colors, decoration, etc., it's just visualization. But for GIS software or database, it's a point, or precisely it's a coordinate of that point. Okay, and when you join these points together, like one point join to next point, join to next point, so it becomes your line or string. It's a line. So if you are creating the road layer, for example, you are digitizing the road layer, what you are doing, you are putting the points. Software is registering the values for that coordinates and it joins the points, so it become a line for you or road for you. Okay, and when you join the different lines together, so software is giving you the polygon or area. So basically what you are doing in the digitization, if you see the technically, just registering the coordinates of each point. So software will store or database will store just coordinate. It is the points location means coordinates. It is storing from that coordinates or from that points you will get the points, you will get the polygon. That is as simple as that. Okay, clear? Admit all. Okay, now when you digitize, now there are the you can see the two modes. One is the point mode. In a point mode, what happens? Person, if I am digitizing, I will put point as per my wish. I will put point as per my wish. If the feature is more curvy, I will put more point. If feature is straight line feature, I will put very less point, because there is no need to put the more points and increase the data size. So that freedom user is having. So point mode of digitization. Another one is a stream mode of digitization. In stream mode, what you do? You will suggest software that at every 5 meter there should be 1 point, or you will suggest software that at every, say, 2 seconds or 5 seconds there should be 1 point. So based on that you will just move your cursor, software will automatically put the point, so you need not to click. So that is but the data size in this case will be more, whether required or not. Based on a specified interval, software will put the point there. So point mode of digitization and stream mode of digitization. So these are the two types of digitization when you digitize the any of the feature. Now this is one more important component when you are when you are creating the database. Now we saw that how to create the data in a GIS, either with existing available source or creating our own data. But when you are looking after a project, so though data is important, but you should not put everything and anything into your database. So you have to limit the level of inputs. You have to limit the number of layers or number of data sets. If you are putting more data sets which is not being used in a project or in analysis, so it will do, it will increase the volume and it will slow down your analysis process. Okay, if you are having 5 data sets, you will get results in 5 minutes. If you are having 50 data sets, it will take few hours. So only required information need to be go in your database. And now how you will decide which is used or not, because first you will create the database, then you will go for the analysis. So how you will know? So there will be always confusion, और इसको हम रख लेते, हो सकता है तो यूज करेंगे बाद में, नहीं तो रहेगा. So if you are going in this approach, so definitely you will collect lot of garbage in your database which will not be used in analysis. So to find out what is required, what is must and what is not, so you should have very clear cut defined objectives and goals. If you know my objective is this, and for this objective I require 1 2 3 4 5 data sets, then it will be very clear picture for you, and you will put a gate, only required things will go into your database. Similarly, I don't emphasize more on the exotic database. Okay, if you have local database available, that will be more relevant, provided that it should be error free and authentic. So nowadays what happens, if you say the data immediately, for anything we used to go to the web and we download from there, and I believe on me, in 80-90% cases we never check the authenticity, reliability and the quality of the data. Simply we download and use it. In this case, uh, the results may not be having appropriate, because we don't know about the input data. If I will not say you don't use that data, you definitely use that data, but first you check its quality, check its authenticity. If it is from the authenticated source, definitely you can use, but don't use blindly. So always use the best, most accurate data to get the right results. And when I say the accuracy of the data, you need to define what accuracy you want. For example, if you are creating, say, a database which you are expecting that my all data should have 20 by 20 pixel size, for example, and you are creating the data 20 by 20 meter, and if you get the data which is available at any other source which is 100 by 100 pixel size, 100 by 100 meter, no doubt you can use that data. You can use for the analysis also, it will work perfectly all right. But the information it is having 100 by 100 meter. Okay, you got my point. So that is 5 times bigger in resolution which you are expected. So if you are using one data of that size and rest of the data are at 20 by 20 meter pixels, so you can imagine the output will be 100 by 100 meter. So instead of getting good results, you will degrade the rest of the data also. So level of accuracy is more important. Another thing mostly happens when you create the GIS database, like if anything we get the data, we put everything. For example, if you are having one layer, and in that one layer there are the 50 attribute columns, so you bring that layer and put into your database and there will be 50 columns, and you provide this data to someone and ask him analyze the data. So that poor that poor fellow will cry with the 50 columns, and by chance if you select wrong column, all your analysis will go wrong. So you put a gate, you put a ladder that only required accurate, error-free, authenticate data will go in my GIS data. Then you will be in safe zone. Okay. Now, once you have special data with you, then another point you will capture the relevant attribute data. Either you generate your non-special data, you use your special data on your system or on your server, or you can download and you can use. So that data you use, create or download, and then you link with the your special data. Now, how you link this external data with your data? Okay, so very simple way is there. So in your, there should be one common field in your non-special data. There will be an attribute field, so one column should be common, whatever you call it, it's a primary ID technically, but uh, there should be one field which should have the common attribute like your special data. So based on that, both the data sets will join together. It's a very hassle-free process. Easily you can join. Okay. Now, to catch the step up to here, just I want to know from you. Can you give me any example of point? Anyone? Any real-time example of point data?
Sir, like a temple.
Like
GPS
the
location.
Temple, position of temple.
GPS locations. Yeah.
Sir, can you please explain what you want to ask?
yeah, what you gave example is correct. I was asking real-time example.
Yeah.
GPS navigational data, sir.
Someone has made me the
Oh, sorry, it was my connection was jumped. Someone was calling. So, am I audible?
Yes, sir.
Yes. Wait, I'm unable to share the screen. Let me try. So, by that time, can you give me the example of any feature which you will map using line?
Railway tracks and river lines, road lines.
Exactly. So, any linear features that is good to map using the this one your line features, and any real-time example where you will use the polygon features.
Polygon features for the height, meters height and mountains height, like
Mm, no, any better example.
area of field.
House and pond.
Pond,
House,
lake,
River.
yeah,
ocean.
pond, lake, land use, land cover, forest, soils, geological maps, right? So you have to choose the appropriate feature. Okay.
okay, sir.
Yeah, perfect. So let me um, check I can share the screen or not. Okay, perfectly fine. But still now, is it everything is okay? I am unable to share my screen.
Sir, please check.
Acha.
Somebody with the name
Anyone is having
Ritesh.
host permission?
Yeah, somebody with the name Ritesh is now host. That's why you are not able to share the screen. Hello, I was accidentally made host. I don't know why. Yeah, but if Ritesh, for the timing, you give permission to sir for sharing the screen. They will figure out what has happened. Can you explain how to find the option to give permission?
Hope it's visible.
Yes, sir.
Yeah. So based on the feature, what we will do, we will select the proper type, either point, line, or polygon, and then what we do, we link this to the databases. We see is whether its database is in your computer, it's a server, it's some government organization, non-government organization, web server, cloud, you can link. Okay, now let me admit this one. Yeah, so then there is a concept called metadata. So after you now you have your special data, your non-special data. So you have these data sets ready. So then what you want to create your data, you want to store your data, you want to utilize your data. So before that, what you will do, you will create the metadata. So what is a metadata? Metadata is data about data. Okay, it will give brief information about the data. Okay, so like it will provide you what is the content, what is the type, who has created the data, when was created the data. It will say something about the quality of the data. It will give you special reference of or projection information of the data. Okay, so basically it will summarize, it will provide summary, about brief summary. I mean, your database will be big, it will be having say 150 layers, but the metadata will give you the glimpse. So data is having 100 layers, data is having this projection parameter, data is created for so and so project, data is created by so and so organization. So it will give you the abstract. So in a one go, it will give a glance information about the data, so that anyone can see the metadata and he will get a flavor about what it is in the data. So basically it's a summary, right? Now when you create the metadata, if I create and if I put the summary or index as per my wish, you will not understand. Or if you create your own things, I may not understand. You will give some fancy names, you will give some nomenclature, some index, which others will not understand, right? So there should be certain standard, like ISO, you know the standard, ISI, you know the standard. So based on the certain standard, this metadata is created so that anyone can go through it and understand, right? So certain details you have to put into the metadata so that others can easily understand, or even if you again over the period of time want to see, you will also get the insight about the data. So there are some standards like ISO 19115 is one of the standard. Then ISO TC 211 is one of the standard. FGDC is one of the standards. So based on these standards, the formats are fixed, files formats are fixed. So that anyone can understand, anyone can create his standard metadata using these formats. So when you create the metadata, you have to ask certain questions so that uh, you will create the right metadata. In fact, if you are using certain standards, available standards, so automatically these questions will be answered. Like what this data describes, what is the data about, who has created the data, and why it was created, what is the quality. So all these questions, quality, reliability, standards, everything will be covered in the metadata itself, so that anyone who is going to use that data, he will get full insight before using the data. Okay, now you have created the database, you have used the metadata, you have linked your data, non-special data and special data, everything is ready. Now what you will do the next? You have to show the results, no? You have to present the results, or you have to use these results on the websites. So for that, you will require map to be composed, and which you did last week. Did you enjoy map composition last week?
Yes, sir.
And I hope everyone is comfortable in that. So I will not put much time here because already you had this exercise. And rightly, some of you, I don't remember the name, he told me, I asked what is a map. So exactly definition that the gentleman or gentle lady told me. So it's a representation of 3D surface on a 2D. That is the definition. And that can be whole part or some of the part. So you use some conventional signs, you use some legends, you use some colors, and you compose the map. So to make it a holistic representation of features on a paper, so that anyone can read it, anyone can see. Map will be almost your final output, so anyone can go through it. Whatever analysis you did, whatever information you generated, that is for user, and looking to the map, so user can use or draw some information out of it. So that is the reference framework, or you can say the map. So map, I know you know all the map elements and all, and you understand the map composition. Now in GIS, recording is on. Let me check. Okay, recording is going on, no problem. Yeah, in GIS, your data will be definitely incomplete if it is not having the projection. Okay, so I hope everyone understand what is the map projection. I'm not going in detail, but map projection is nothing but your map should sit exactly on Earth's surface. All the features should sit exactly on Earth's surface. If I say, if I draw the urban boundary of New Delhi, for example, on my map, so that boundary should exactly fit at New Delhi, right? So that is the purpose. If I say Parliament House, I have a point, Parliament House, so that point should exactly fit onto the Parliament House. So that is the purpose. So for this, basically what we are doing, Earth is a 3D, we are representing that 3D on a 2D surface. So for that we are using this map projections. Okay. Now, if you are reading your text, your note, you will find the word georeferencing. So what we do, georeferencing means we are creating a data where the data we are providing its latitude and longitude, or you can say projection information. So how, I hope you had a practical session where you use one projected map, maybe toposit I think you have used, and you have used another map which is not having projection. So what you did, you transferred the projection from one map which is having projection to another projection, another map, and that map become projected or georeference. So that is the georeferencing. But there are some other terms coming in between, which which makes little confusion, like geocoding. Sometimes it create confusion. So geocoding is nothing but what you are doing, you are transferring your coordinates to the features. For example, road, you are geocoding it. Okay, you have Lal Bahadur Shastri Road. So you are putting its coordinates. So through the coordinates also you can call or you can identify the Lal Bahadur Shastri Road. Another is geotagging. सोशल मीडिया में बहुत चलता है टैग करना, टैगिंग, टैग. So geotagging means if you have any feature or may say photograph, so you can tag that photograph with your coordinates. That is a geotagging. Okay, and one more term you will come to know, that rubber sheeting. So this comes somewhere in GIS while you working in the project. So rubber sheeting is that you have two different maps of adjusting areas. One team has prepared this map, another team has prepared this map, and you are a manager for both the teams, and you want to make a seamless mosaic of both the maps. Now what happens? There is a slight variation in the edges, very slight variation. So what you will do, you will just adjust these two maps. Maybe you will pull one map up or down and you will adjust the exact boundaries so that there will not be any unnecessary curve or gap. So that is nothing but the rubber setting. Okay. So the standards I will not touch now. So everyone please give attention to the screen. Can you identify this lady?
Katrina Kaif, I
Yes.
think.
I thought you will not able to identify because you are not watching the movies. But
Sorry, sir. I am not interested more in movies.
but this shows that your batch is watching the movies. Okay, good. So I'll put another picture. Hope I will not ask. Can you identify? I hope everyone knows these are the famous personalities. But putting these pictures here is not on any discussion on Hollywood and Bollywood. But I just want to ask few more questions. Now I'm putting one more thing, and can you draw any inference from this? Have you seen the picture came up on the screen?
Yes, sir.
This,
Yes, sir.
yeah, this picture. Can anyone interpret?
The arrow is showing the distance, and the second
And
one arrow.
it's showing the curve. Second is showing the curve.
I think since many batches, I think at least 3-4 batches I have used the same picture, so old slide, and I was almost asking the same questions with some purpose in my mind, but the answer you gave is extra brilliant. Very good, very good answer.
Thank you, sir.
Now I will put some more feature. Can you see the blue arrow?
Yes, sir.
Yes, sir.
So what you will say, interpret from this?
Some connection with this lady.
It's head distance from head to head.
Okay, distance from head to head, good. Okay, I'll put one more arrow.
It's also same, sir.
Okay.
It flipped from one picture to another.
One more arrow. Okay, but
there is a relationship between each other.
yeah, there is some relationship. Okay, very fine. But if I don't have this, now you have interpreted this data. I mean, you drawn some conclusion. Okay, without any objective. You are not having any objective in mind, but still you told me, oh, there is some distance, there is some curvature in the distance, there is some relationship. There is some relationship. It's the most important concept in the GIS, and that relationship. Now you don't consider these pictures. you consider this an object on the earth, and of course they are objects. Okay, anything in your map, that is object. So this relationship, this is the relationship in GIS, and without relationship in the objects, it's very difficult to make a conclusion or make an analysis using these features. Okay, so this relationship of between the geographical objects, can anyone tell me what is the term for this relationship?
Relationships are
And
like.
let me tell you, during the last practical session, some of you have downloaded the data from some site, and when you were analyzing the data, that time you got the error, topological error. You got the topological error?
Yes, sir.
Some of you, may not be all, but some of you got the topological error, and then you fixed it. Then you fixed it error. So one particular feature in that object was open. So because of that, that error was coming, right? So what is the relationship between these objects is known in GIS. There is some nomenclature. Anyone knows that?
Interpolation, sir.
The physical
No,
physical
no,
features, sir.
no. These all are the features.
Topology.
My dear friend, say it loudly.
Sir, Katrina Kaif and Kareena Kapoor,
No.
both are
Answer.
the.
No. Answer came from some corner, but that my dear friend is shy. If you say that word and if it is blunder, so we all will laugh at him.
Topographical.
No.
Topology.
One of you say it loudly, man.
The geospatial relationship. These are critical features.
Interpolation.
No. Earlier you told the right terminology.
Sir, physical features, sir.
The
No,
topological features.
Exactly, Vijay, you were saying this earlier, right?
No, sir.
Spatial
Actually, some
relation.
other guys said it. I just.
No, I know now Shubham
Yes,
has
sir.
said, but earlier
Yes, sir.
Vijay was
Yes, sir. Earlier,
whispering.
Mr. Vijay was telling the right, but I
So
didn't.
anyway, so my dear friends, please don't forget this topological. Topology is a very important concept in GIS, and let me tell you, you all are using Google Maps for navigation. Ola, Uber, many companies, and we all are using. If you don't know the location, we open the Google Map and we navigate. आग बंद करके उस पर नेविगेट करता है, कभी कभी आपको ब्लंडर गलत जगह पे भी लेके जाता है, मुझे भी लेके गया बहुत बार. But anyway, so we all are using Google Maps, and what it is using topology, it is using the Katrina Kaif and relationship which you are defining here. It is using the same concept, and which is built based on the topological. So if you have a topology, so now let me move ahead. So that is the topology, and if you have the topology built up on your database, so your each feature in the database will talk with each other. Like I am communicating with you, so your each feature will know who is at my right, who is at my left, how much distance. So everything your map, your data can guide. Okay, so the concept is known as topology, which you face the error during the exercise. Because of the time, I could not explain why it is coming, because we have 4 exercise on the plate. So that error was coming because that one feature was an island, is not talking with each other. So that's why that error is coming. When you cleared, fix that topological error, layer was okay. So topology is a very important concept in the GIS. When you face any problem in the analysis, so close your eyes and run the topology, it will fix the error. It will show you which feature is having error, so that all the feature will ready for the analysis. Okay, don't ignore topological errors. Otherwise, sometimes I saw it shows topological error. So learners, they go to the attribute table and delete that feature. So don't delete it, fix it. There are ways, many ways to fix, which one way you saw during last practical. Okay, so the concept of topology is very important in case of the GIS database. Even I will suggest you create the database, check the topology. If it's running fine, your data is perfectly all right for any kind of analysis. Okay. So already we discussed this slide. So it's a relationship, spatial relationship among your different objects in a database. So if you have topology, your all objects, they know the distance of each object, direction of each object, connectivity. If you are talking about the roads or electricity or canals, they know the connectivity also. Okay, if you have road database, it is yeah, and that is having topology built up in, so you will be having speed of the road. That's why Google is giving you distance is 60 kilometer, you require 1 hour 21 minutes. How, from where it is coming? So because of the topology, it is using the attributes which are there in the road layer, and it is calculating and giving us the results. So that is the topology concept. Now, as we know point, line, and polygon. In topology, there is a concept of point. Point we know, vertex, that is line. These are the vertices, dots, that is nothing but the points, and nodes. Now, what is the difference between vertex and nodes? Vertex can be anywhere in the line, but nodes,
At the end.
there will be always junction. Okay,
Yeah.
another line is going from that. So in topology, this is very important. Why important? Because if your any feature or any object is moving, let me put this one pointer. Yeah, see this red color object. If you want to move your car in this direction and you want to make a turn, so it's not possible until and unless you get this node, right? This nothing but the junction on the road. So this is called node. And line, arc, and polygon, which we know earlier. So these are the terminologies used in a topological concept. I hope it's easy to understand because already we have seen earlier. Okay. So there are enormous numbers examples of using the topological modeling. All we know, Google Maps, they are also using. There are various models available. If you want to move, say, electricity, or if you want to move the water through the canals or pipelines, so everywhere you can use. Without topological concept, it's not possible to analyze this in the GIS. Okay. Now, topology, anyone is having any doubt?
No, sir.
Are you fully convinced topology?
Okay. Yes, sir.
Very, very important part in a GIS database. Now we have seen one polygon earlier, how it was connected in line with that only. So consider here this polygon C, right? So this polygon C, now we have seen the nodes. You remember we have seen the nodes in earlier PPT. So this polygon C is having the node list. Node list, this is 4, 8, and 3. So this is 4, this is node 4, this is 8, and this is 3. So this polygon C is bounded by these 3 nodes, and these 3 nodes are linked with the arc or lines. So you can move any goods, any features along these lines. So you will get perfect information. Okay. Now this is your one area. For example, C is in one area. Now B will be your another area which is having the similar nodes, lines. G will be your another area. So in this way, whole network in the database is built through the topology. You link your special features with your non-special features. Now all these are the A, B, C or 1, 2, 3, 4, whatever attributes you are seeing, these are the non-features, but they are linked together and they are being used in any of the model. There are few models, so for all the models, the structure will be the same. So in this way, you can get the information. Okay. So before moving, is there any doubt up to here, especially in topology and how the attributes are linked and used in a model? No doubt?
Sir, is there any standard rule for GIS platform for topology? Standard SOP rules?
Yeah, there are standard rules. Of course, there are standard rules. But see, ideally, these problems come through the error. Mostly either through the digitization or through linking that. Now, how these errors are coming, and then I will come to the standard rules. Let me admit. For example, if you are manually digitizing, okay, and while digitizing, you might have seen we fix the tolerance limit, no tolerance limit. Okay, so what it means that when you end your cursor, double click, so automatically it will join to the nearest node. Okay, and you give that distance, tolerance limit. But sometimes uh, uh, you are ending more than that limit. Okay, now ideally it should not end, polygon should not close ideally, but sometime it closes because of some error. It gets closed for time being. Basically it is not closed, but it shows closed. And that open polygon, now if you see this polygon C, if it is open here, it's not closed, then this cannot be a polygon. It will become line. Technically it will be line, it cannot be polygon. Polygon should be closed and circled. So if you run anything on the polygon, this particular fellow C, he will give you topological error. He will take his flag and he will stand, no, this operation is not possible, I am having error. So this is the error. Now when you fix the error, even this topological error, each software is having its own way to fix it, so and its own methodology to fix it. Sometimes some softwares will ask you to delete the feature, some software will ask you to rectify the feature. So there are standard procedures for each software and you can fix it. Okay.
सर एक क्वेश्चन है सर.
हाँ हाँ
सर जैसे मान लीजिए ग्लेशियर है किसी माउंटेन पे, तो उसका
हाँ.
एक जैसे इसका स्पेशल फीचर होगा कुछ, तो उस केस में जो टोपोलॉजी है उसकी, वो चेंज हो जाएगी या वैसे रहेगी? क्योंकि अगर मान लीजिए मेल्ट हो रहा है, मेल्ट होकर नीचे आ रहा है वो, तो उसकी टोपोलॉजी सेम रहेगी या चेंज हो जाएगी?
See, GIS data, I tell you practically, is nothing to do with features. I mean features as per our understanding. Okay, please understand this. For us, it's a glacier feature. For us, it's a glacier. For GIS layer or GIS data, it's nothing but only point, line, and polygon. GIS doesn't understand it's a glacier, it's forest, or it's water body, or it's habitation. Okay, for it, it's just polygon. Okay, Now, if your glacier melts, now you created the database, your glacier melts, 50% कम हो गया, summer आ गया, कम हुआ. So, whatever data you generated is for that particular date. That is clear. If you want to say, if you want to show that now glacier is 50% melted, so you have to create one more layer, or you have to edit within that layer. For example, this polygon C is your glacier layer, and your glacier melted to the half. So either you have to create another layer, or you have to make one more polygon and divide this into two, original glacier and melted glacier. Once you did this, then your topology, your data will understand, I am the old fellow, half polygon, I am the old, rest is the melted one. So this way this topology can understand. Okay.
So that means the topology will change.
Topology, instead of saying topology change, because we can say the polygon will reduce in its area.
Data is changed, sir. I think.
Data will change, yes. Either you have to create new layer, or you have to modify the existing layer. Whatever you do, topology will understand until and unless there is error. If there is not error, it will understand based on your attribute. It will understand. If you ask what are the melted areas, it will give you, or it will give you the difference between original and melted, how much area reduced. It will give you this much square kilometer area is reduced. But once you have to edit the database, then only it will provide. Okay. Shall I move ahead?
Sir, one question, sir. In the neighbors point in this tabular column, what are these hyphens like these B, D, C?
This.
These
So
this
see,
yes,
these are the neighbors. This is say B is a polygon, D is a polygon. This
yes,
B
sir.
and D are the neighbors.
Other than the one, this thing, what we say is hyphen or hash.
No, this is just a depiction that this B is also having neighbors.
Yes.
D is also
Sir, I
having neighbors.
guess,
That means
sir, I guess
it's just connection.
A
Oh,
connected to B and D. It's like that, I
Yeah.
guess.
So its meaning is that, see, this A polygon is having two neighbors. If you, this is because why, if you want to find out who is at north direction of
oh, okay,
A,
okay, got it, sir.
so immediately it will be B, or who is at north direction of
No, no sound.
शीला देवी बन गए
हेलो कमल, am I audible to you, Mr. कमल?
सर डिस्कनेक्ट हो गए।
नहीं, कमल ऑडिबल है क्या? कमल राणा।
हेलो, यस यस
ब्रो, कैन यू वो जो टोपोग्राफिकल में जैसे जो फिगर बन रहा है, ठीक है,
हाँ 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 हाँ।
तो वो कंफर्म कैसे हो रहा है कि वो एग्जैक्ट फिगर वही है? कि जैसे पॉइंट पॉइंट बना लिया, नोट्स बना लिया, है ना,
नहीं नहीं,
उसके बाद
एक्चुअली
वो
एक्चुअली क्या है
एग्जैक्टली
उसका,
कैसे पता चलेगा?
हाँ हाँ हाँ, उसका मैं बताता हूँ आपको।
हाँ हाँ
उसमें आप वो जो डायग्राम है, उस डायग्राम में आप देखिए ABCDEFG करके
हाँ
सारे वो प्लॉट हैं, उसको
हाँ
बाकी कुछ
हाँ
मत
हाँ।
कंसीडर करो, आप प्लॉट कंसीडर करो।
नहीं, वो
जैसे
तो सही है, वो तो,
हाँ हाँ
पर वो कंफर्म कैसे हो रहा है कि वही है? गलत भी तो हो सकता है, जो है ना,
हाँ, मैं
एरर भी
वो
तो।
उसी पे, हाँ हाँ, मैं उसी पे आ रहा हूँ। एक्चुअली उसमें क्या
हाँ
है, टोपोलॉजी एक कंसेप्ट है, उसमें अगर वो जो 5 प्लॉट हैं, जब आप उसको उन 5 प्लॉट के ऊपर एक टोपोलॉजी बनाएंगे, तो उस
हाँ हाँ
टोपोलॉजी से आपको पता चलेगा कि ऑल दीज 5 प्लॉट्स आर कनेक्टेड विद ईच अदर। अब सपोज वो कनेक्टेड हैं, उनके बीच में कोई
हम्म
गैप नहीं है, जो बीच में सूडो नोड्स आ रहे हैं सारे, अगर वो एक
हम्म
दूसरे के साथ कनेक्टेड है, स्नैप्ड है, तो समझो आपका डाटा एकदम करेक्ट है। अगर इन केस प्लॉट ए प्लॉट बी के साथ माइनर गैप शो करता है, कहीं
हम्म।
वर्टेक्स एक की बजाय एक साइड दो लगे हुए हैं, तो वो मतलब थोड़ा सा गैप आ जाएगा उसमें। जब थोड़ा सा भी उसमें गैप होगा, तो वो टोपोलॉजी जब रन करेंगे तो वो ऑटोमेटिकली उसको रेड कलर में शो करेगा। ठीक है,
अच्छा अच्छा,
तो
मतलब वो
आप
सॉफ्टवेयर पे दिखा देगा
पर्टिकुलर
वहाँ पे।
पर्टिकुलर उस पॉइंट पे चले जाएंगे, क्योंकि वो रेड कलर आपको एकदम पॉइंट करेगा वहां पे जाके कि यहाँ पे कुछ मिस्टेक है, कुछ एरर है, तो आप
क्योंकि
देखेंगे कि
क्योंकि
वहां पे
मीटर
एरर।
मीटर का भी डिफरेंस एक एक, वो तो बिल्कुल एग्जैक्ट, जैसे मीटर का भी डिफरेंस हो जाएगा तो गलत हो जाएगा ना, मान लीजिए
हाँ,
थोड़ा सा भी।
नहीं नहीं, क्योंकि पता क्या, मीटर का अगर गैप आएगा तब तो वो एकदम ब्लंडर आपको वैसे बिना टोपोलॉजी के भी कई बार दिख जाएगा कि नहीं, देखो यहाँ पे कितना ज्यादा गैप रह गया।
हाँ
बट कई
हाँ
बार क्या
हाँ।
होता है कि एक मतलब सपोज करो, अब 2 प्लॉट आपस में एडजॉइनिंग हैं, तो उसका
हम्म
स्टार्टिंग पॉइंट और एंडिंग पॉइंट में दो दो नोड्स और दो मतलब दो नोड्स होंगे, तो वो एकदम करेक्ट आपस में स्नैप्ड है। अगर बीच में एक साइड में एक वर्टेक्स लगा होगा, नोड लगा होगा, तो वो आपस में स्नैप नहीं होंगे, तो वहां पे वो टोपोलॉजिकल एरर बताएगा। तो इसका मतलब
अच्छा,
कंसेप्ट ये है कि ये जो 5 प्लॉट अभी दिख रहे हैं, वो
हाँ
एकदम
हाँ।
करेक्ट है, उनमें कोई गैप नहीं है। बट इसमें एक एग्जांपल और ऐड करना चाहिए था साथ में
मतलब इसमें
कि ये
एरर 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 यही वाले आते हैं कि मान लीजिए वर्टेक्स पे, नोड पे दिक्कत है या वर्टेक्स पे दिक्कत है ना, वो
हाँ हाँ
टाइप का मोस्टली।
हाँ, तो ये तो हो गया ना प्लॉट प्लॉट वाला कंसेप्ट की। जैसे ठीक
हाँ
है, कोई
हाँ हाँ
पॉलीगॉन है, जैसे पॉइंट में
हाँ।
कैसे ढूंढेंगे आप, पॉइंट में कब कैसे
जैसे
ढूंढते हैं
उस दिन
आप,
वो
जैसे
बताया था,
हाँ
इग्नू इग्नू की बिल्डिंग बनवाई थी ना फर्स्ट वाली क्लास में,
हाँ हाँ,
तो जैसे
तो
मार्क किया था, पॉलीगॉन बनाया था बेसिक सा, ऊपर से उसको कवर कर दिया था प्रोजेक्ट करके।
हाँ हाँ
प, वो तो जैसे एक सिंपल प्रोजेक्शन हो गया एक, है ना, पर अगर जैसे थ्री डी में तो गलत भी हो सकता है ना, एरर एरर काफी आ सकते हैं, तो इसीलिए
हाँ
मैंने
हाँ,
पूछा।
नहीं नहीं, एक्चुअली क्या है, आप 3D एट द एंड करेंगे ना, जब सब आपकी जो रेक्टिफिकेशन पूरी डन हो जाएगी, पूरा आपका डाटा
हाँ
करेक्ट हो जाएगा, आपको लगेगा कि जो मैंने जियोमेट्री बनाई है, क्योंकि
हाँ
मतलब सपोज करो मेनली चांसेस होते हैं, जो हमने मतलब अभी आज हमने कंसेप्ट रीड किया, ऑन क्रिएशन में क्या होता है कि हम मैनुअली क्रिएट कर रहे हैं, तो मैनुअली क्रिएशन में सबसे ज्यादा एरर फाइंड आउट होती है। ठीक है, तो
अच्छा
उसमें
अच्छा।
क्या रहता है कि सपोज करो आपके पास, आप मैनुअली पॉलीगन ड्रॉ कर रहे हैं, और मैं मतलब नंबर 1 1 to लेके 10 तक आपने एक दूसरे के साथ एडजॉइनिंग है सारे, आपने खुद ही मतलब उनको डिजिटाइज किया हुआ है। तो उस
हम्म
केस में जो मैनुअली डिजिटाइजेशन होती है, उसमें सबसे ज्यादा मतलब चांसेस रहते हैं कि आपकी एरर्स रहेंगी वहां पे। फिर उसके बाद जैसे आप डिजिटाइज डन करेंगे, एट द एंड एक टोपोलॉजी कंसेप्ट होता है, उस टोपोलॉजी को बिल्ड करना पड़ता है, जो कि फाइल जियो डेटाबेस के अंदर जाके जो डेटा सेट रहता है, उस डेटा सेट के ऊपर वो टोपोलॉजी बनती है। उस डेटा सेट के अंदर कितने फीचर क्लासेस हैं, लाइन है, पॉइंट है, पॉलीगॉन है, नंबर ऑफ होगा,
हाँ, वो
उसमें
जो भी
सब
मतलब
कुछ।
स्पेसिफाइड है, हाँ उस हिसाब
हाँ,
से।
वो स्पेसिफाइड है, वो आपको एक ऑप्शन देता है। ये टोपोलॉजी
हम्म।
आपने कहाँ पे रन करनी है, पॉइंट पे भी करनी है, लाइन पे भी करनी है, सब जगह करनी है, तो वो उसके हिसाब से रन करेगी। तो वो पॉइंट, सपोज करो पॉइंट की एरर आपने आइडेंटिफाई करनी है, तो पॉइंट की कैसे
हाँ
करेंगे? पॉइंट पॉइंट के लिए डिफरेंट रूल होता है। जैसे उसमें आइडेंटिकल है, आइडेंटिकल का मतलब है कि एक पॉइंट के ऊपर एक पॉइंट हमने मिस्टेक से ऊपर और
हाँ, आ गया तो उसको कैसे हटाओगे?
हाँ,
पॉइंट
उसको
के ऊपर
कैसे
पॉइंट
हटाओगे?
आना चाहिए
तो
ना।
वो, हाँ, वो भी आइडेंटिकल, वो भी टोपोलॉजी से ही हटेगा। लाइन के केस में क्या है? लाइन के केस में भी डुप्लीकेसी आइडेंटिकल भी रहेगा, और साथ में जैसे सर ने आज बताया कि एट द एंड नोड्स होगा। वहां पे सपोज करो वहां पे पॉइंट नहीं लगा है,
हाँ
एंड पॉइंट है, जैसे एंड पॉइंट बोलते हैं जिसको, एंड पॉइंट पे
हाँ
हमारे पास कोई डाटा नहीं है, कोई सोर्स मतलब कुछ था नहीं वहां पे। तो जैसे एक रोड है, रोड का डेड एंड होता है
नल
ना।
नल 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 वॉइड कह लो, वॉइड कह सकते हैं ना, नल
हाँ,
वैल्यू या
नल वॉइड
वॉइड।
वो कह सकते हैं। तो वहां पे
हाँ
जब टोपोलॉजी रन करेगी, तो वो एंड ऑफ द रोड जो होगा, वहां पे वो उसको नोड में शो करेगा। वो भी एक रेड कलर का आएगा। तो आप वहां पे आप देखेंगे जाके कि नहीं, यहाँ पे तो डेड एंड है रोड का, तो यहाँ पे कुछ हो नहीं सकता है। तो मतलब उसको आप अवॉइड कर सकते हैं। बट इन बिटवीन अगर सपोज करो डेड एंड और बीच में अगर रोड के बीच में कुछ आ जाता है, जैसे जंक्शन पॉइंट है, जैसे
हाँ
एक रोड से
हाँ,
मल्टीपल
मोड़ है,
रोड निकल
कोई
रहे हैं।
कोई मोड़ है,
हाँ,
जंक्शन है।
हाँ, जैसे जंक्शन, आज जैसे सर ने एग्जांपल दिया, मतलब जंक्शन है। अब जंक्शन
हम्म
वाला रोड जो है प्रॉपरली स्नैप नहीं है मेन रोड से, तो वहां
हम्म।
पे वो एरर शो करेगा टोपोलॉजी में, जब आप टोपोलॉजी रन करेंगे। तो ये टोपोलॉजी एक कंसेप्ट है हमारे डाटा को रेक्टिफिकेशन करने के लिए, उसको एकदम मतलब एरर फ्री करने के लिए, जैसे हम कह सकते हैं, वो इजीएस्ट वे है, और मतलब बेस्ट कंसेप्ट है वो सबसे ज्यादा। और विदाउट
हाँ, इम्पोर्टेंट है
टोपोलॉजी।
ना, इसलिए मैंने
हाँ,
क्लैरिफाई
हाँ,
कर लिया थोड़ा सा आपसे।
जी, जी,
एक्सक्यूज मी सर।
ओके ओके, थैंक यू।
कमल जी।
वेलकम।
हेलो।
जी,
सर मुझे होस्ट किसने बना दिया ये? मैं तो मुझे हटाना भी नहीं आ रहा ये।
ये शायद सर की तरफ से हुआ होगा, हम हमारे पास तो है नहीं ना अथॉरिटीज की।
वो मैं मुझे होस्ट रखा हुआ है इसमें।
नहीं, 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 आप उसकी चिंता ना करें, क्योंकि सर शायद वहां से कुछ क्लिक हो गया होगा, क्योंकि जो होस्ट होते हैं उन्हीं से कुछ ना कुछ हुआ होगा थोड़ा बहुत, तो इसकी वजह से शायद हो गया होगा। आप उसके लिए टेंशन ना हो जाएं, क्योंकि वो सर आप खुद देख लेंगे उसके लिए।
अच्छा
क्योंकि
अच्छा,
मुझे
ठीक
मैसेज
है।
मुझे मैसेज आया था यहाँ पे कि नाउ शीला देवी जी होस्ट है, तो फिर मैंने देखा कि थोड़ा कुछ मिस्टेक हो गया होगा शायद, तो सर शायद देख रहे होंगे उसको।
अच्छा अच्छा, ठीक है। ओके
कमल
थैंक।
जी, गुड आफ्टरनून।
गुड आफ्टरनून जी।
कमल जी, अब तक जो सर ने कराया है जितना भी, इसमें कोई असाइनमेंट वगैरह भी दिया है हमें करने के लिए?
जी, असाइनमेंट तो लेबोरेटरी के लिए है ना, 104L जो है की जो
10।
असाइनमेंट है, वो जो भी
जी
काउंसलिंग क्लासेस जो चल रही हैं उसके बारे में, जितनी भी एक्सरसाइज हैं, उस एक्सरसाइज के एंड में
जी।
लेबोरेटरी एक्सरसाइज के लिए कुछ क्वेश्चन दिए गए हैं। वो
हम्म,
तो मतलब हमें करने पड़ेंगे ना,
जी जी जी।
दिया हुआ है।
ओके, ठीक है ठीक है, थैंक यू।
वेलकम जी।
Sorry, learners. Yeah, I was disconnected again.
Okay, sir.
Okay.
And I think you were disconnected, and Miss Sheila Devi automatically she has been created host. So she was worrying and how to. She was asking to कि host कैसे हटाया जाएगा.
Okay. Maybe. Now she can create host to me.
Yeah, she can, but sir, I think she was confused a little bit. So where is the option? So from where she can? Yeah,
Actually, that was a maybe reason I was disconnected.
yeah. I
Now
understand, sir, because
I was
automatic.
unable to share the screen now.
Yeah, that's why, sir. So because she is the host now.
Yeah, can you make me the host so that I can share the screen? So by that time, I hope there is no any doubt, confusion related to topology.
No, sir, not at all.
Okay. So now by the time I can share the screen, I will go ahead on integration. Okay, so because it's not necessary that you will create a single file of a huge database, or it is also not possible to create a only one file having multiple database. Okay, so you will be having different files. I can say there will be many files. Even there will be different type of files, vector, raster, and maybe each feature type of feature will have different files. So in a nutshell, there will be different database, different files you are having. So you need to integrate. Right now, only we have seen the spatial and non-spatial data. Apart from that, say you are doing seamless mapping, for example, say for a state, and you have files. Not still, I am not able to share the screen. And say in a state, you will be having say around 20 districts. So each district will be having a file. Say for example, land use land cover, each district you are having 20 files. So what you need to do when you want to go for the analysis, then you need to have a single file for a state. So what you need to do, you have to integrate all 20 files into one. So that will be your horizontal integration. Okay, it's not simply joining. It should be natural, no? Okay, so it should be simply seamless. So that is horizontal integration. That integration is horizontal integration. Okay, similarly, now this you are joining horizontal integration. Apart from that, for a same area, for example, district X will be having say 20 layers. Now these 20 layers should sit exactly on top of each other. Everything should be within the boundary of district. So all the layers should seamlessly match. Okay, you have one land use land cover layer, you have say water body layer, you have slopes, you have soils. So all the layers should integrate vertically perfectly. Then only your data will be perfect. So that is called vertical integration. So we will have integration horizontal as well as vertical. Someone is asking me to share the screen, but I am unable to share until and unless someone makes me host. I cannot see screen. Okay.
Sir, Sheila Devi is host. She can do.
So, but Sheila Devi, please make me host. Can you make me host?
Sir, simultaneously you
I
can
don't
share
know
screen,
what
sir,
happened.
and she will give the permission.
Suddenly she become the host and I was dropped from the call.
Sir, please you share your screen. Then she will
No, it is
you.
not allowing, na.
सर मैं
Host
कैसे
has
बनाऊँ इसको
disabled
होस्ट?
comment screen, na. I can.
हेलो हेलो
हाँ,
सर
बोलिए.
सर गाइड कीजिए शीला देवी जी के लिए.
हाँ जी सर, मुझे बताइए कैसे करना है.
Okay, host, make host. Can you right click on my name and see make a host? Go to the participant and you will find 3 dots. Either 3 dots or right click and make me host.
बन गया
Is
सर
it
आप.
showing option?
Sir, now you are the host.
यस
बन
सर.
गए?
यस सर.
अरे धन्यवाद शीला देवी, चक दे फट्टे.
मैं खुद फंस गई थी सर.
Yeah.
मैं सोची क्या करूँ, ये बार-बार एडमिट करने के लिए मैसेज आ रहे थे.
आपने ऐसी क्या मैजिक कर दिया, ऑटोमेटिकली वो स्विच हो गए.
नहीं सर, सबको मौका मिलना चाहिए ना होस्ट बनने का.
वो मुझे पता ही नहीं चला, मैं ड्रॉप हो गया सडनली. ऑटोमेटिकली हुआ समथिंग. Okay. Now hope my screen is visible, huh?
Yes sir, now it's visible.
Yeah. So by the way, we were talking about the horizontal and vertical integration. Okay, so horizontal, you need to join maps which you have created, maybe by through the different streams, or you might have procured some from different sources or different times. So you will join them. That is your horizontal integration. Similarly, different types of map of the same area, they should be vertically integrated. Okay, and spatial and non-spatial integration we have already seen. Now we'll finish this quality issue and then we'll take some break before joining to the next session. So quality is important everywhere and similar in GIS also. So quality is nothing but meeting the specified or defined or required requirement of a particular layer product. It's a common for everything. Okay, so it's fitness to use. If you define the quality, if you define the quality, for example, for the milk, you defined it should have 4.5% fat. That is quality. Okay, similarly for GIS also, database also, you define the quality on various parameters. So it should meet the quality so that it will be fit for a specific use. So for that quality parameters, already we were discussing some parameter. It should be reliable, it should be accurate, it should have generated within specified date, it should be available as timely, it should be relevant to your purpose, it should be very precise and complete with all the features. So these are the some of the aspect of the quality. It will vary from data to data. Okay, but these are the some of the aspects which are common in most of the GIS database. You require data that should follow, that should have these parameters checked before you take the data for the analysis or integration or any kind of use. Okay, so in quality, the accuracy parameter is most important. Of course, all the parameters are important. So accuracy is your correctness, how data is correct or how data is measured close to its actual values. Okay, so that is accuracy. So the accuracy can be either positional accuracy. Positional accuracy means you want to map national highway number 1. So on the ground it should follow national highway number 1. It should not go to 2 meters here and 5 meters there. So that is positional accuracy. Similarly, the attribute accuracy, it should have proper attribute. Okay. Similarly, the semantic accuracy means exact or precise or proper identification of spatial object in the database. You have captured data very nicely, feature very nicely, but you have identified it wrongly. Okay, if it is Mahatma Gandhi statue and you identified it Sardar Vallabhbhai statue, so database will not understand. So that semantic accuracy, attribute accuracy, positional accuracy, all accuracies are very important. If there is any deviation, no matter whatever analysis you run, you will get wrong results. And in the analysis phase, it is very difficult because if you are using 10 layers and in a final output, you are going to search what went wrong, then it is Herculean task. You have to go to each layer and find out. So accuracy is more important. Now, accuracy how close data is from the expected or true value. Okay, you are trying to, if it is matching 100%, it's very good. Practically, it won't be. There will be some error. I mean, I will not say 100% correct. It doesn't happen because there are limitation. If you are putting the line on a line for a feature, so some of the area is also covered by them. So that's why I am saying it's not 100%, but it should be the maximum or it should be close to the true value or expected value. Okay, and the precision is the exact, how much exact data are measured as well as stored. Okay, sometimes we measure the data very precisely, but while storing or while typing or entering, there will be some error. Okay, especially error after points, there will be error. So it's preciseness in measurement as well as storing the data. Okay, sometimes we convert the data from one file format to another file format, and each file format is having its own standard. So there also some small little errors happens. So depend on the precision of your use, that error will also matter sometime. Okay. Now let us understand in a practical way. In the context of the precision and accuracy, these circles, if you see, and let me, yeah, it is there. And this is the data, and this is the area from where you have collected the data. Now, this data says low accuracy, high precision. You have measured very perfectly. You have measured very perfectly with utmost care. Measure is having high precision, but it's not having good accuracy. Okay, next another example. High accuracy but low precision. Okay, and third example. So you are having high precision as well as high accuracy. So the feature is measured very precisely, accurately, and stored properly. So these are very small and minor things, but when you are working on high resolution projects, where you are mapping all features with higher resolution, then this precision and accuracy will matter a lot. If, for example, I just give a practical example. You are creating a footpath along the road in an urban area in any city. So space is defined, I mean width is defined. Say for example, corridor width is 100 meter, that footpath width is 100 meter. If you have error in either precision or accuracy, that 1 meter area, that path is footpath is 1 meter. So if you goes 10 centimeter away, so it will encroach someone's area, someone's building. So I hope you understand the importance of precision and accuracy. So both are very important. But whatever we do, it cannot be precision, accuracy, all depends on the scale. If you are measuring, mapping something on 1:1 million scale, very coarse resolution. So there is a, you cannot have that much separability in the features. You are clubbing many features together. If you are coming to the 1:50,000 scale, then it will be more better in case of the resolution. If you are coming to 1:500, then your small errors will start creating problems. If you are coming again uh, better resolution than 500, then your centimeters level errors will also create a problem. So that depends on the scale, but it is impossible to avoid the 100% avoid the error. You can minimize, you can reduce some of the errors, you can omit, you can fix some of the errors, but you cannot fix all the errors. Okay, so why I am saying this, because there are some inherent errors, or some are the operational errors. Operational errors, yes, you can manage, but the inherent error you cannot manage. For example, error because of the map scale, which I gave example of 1:1 million, 1:50,000, 1:500. So according to the scale, map scale, these errors will be there. But with 1:1 million scale, that much error is acceptable. Is acceptable because that will not create much problem, because scale is very coarse. But if you go to the finer scale, that type of errors cannot be acceptable. Okay, so but these inherent errors you cannot fully control. To some extent you can minimize, but operational errors, yes, you can have control. You can have more efficient, more technical staff. You can take more precautions while performing the analysis, creating the data. Okay, so errors because of the map projection, like if you are using LCC, uh, if I mean depend on the map projection, because map projections, they are based on the mathematical is having certain assumptions also in it. So by default, it will give some inherent error. And once you select that projection type, you cannot, control the error. Similarly, cartographic generalization. If you detail map, you generalize, make it a broad, you don't have any control. Errors, some are errors. Okay, then you completed your projects, you are okay, ready to go, ready to share your output. So that time you require some visualization also. So some output generation, outputs like on some websites, you can display your analysis, or your analytical layers or GIS layers can go into the decision support systems, which can be further used to take decisions. Okay, so this way you can have hard copy, soft copy, your text format, map. Okay, any doubt up to here? Will stop for some time. Again, we'll start. Okay.
No doubt,
Okay.
sir.
Any? Yes, Kamal.
Yes, okay, sir.
Okay. So, do you want some break before starting the next
Yes,
topic?
sir.
Yes,
20
sir.
minutes.
So, how much break you expect?
15 to 20
20
minutes, sir.
minutes.
Okay, so it's 12:40.
1 o'clock.
Sir, we can start at 1.
Okay, so what I will do, I will stay connected and 1 o'clock will start. Okay.
Sir, okay.
सर मेरा एक
Yeah, then
पिछली
we'll complete the.
सर एक मेरा प्रीवियस एक्सरसाइज के रिगार्डिंग एक छोटा सा डाउट था, अगर आप मेरी थोड़ी हेल्प करें तो।
बताइए बताइए।
सर एक्सरसाइज 1 मिनट में बताता हूँ। सर एक्सरसाइज
कौन
21
सा
डेटा
मल्टी क्राइटेरिया मैप?
एक्सरसाइज 21 है ना सर, उसमें सॉरी एक्सरसाइज 22 है। उसमें सर वो जो रेनफॉल वाला और स्लोप वाला जो था ना, वो मैं ट्राई कर रहा हूँ, बट उसका क्लासिफिकेशन नहीं हो रहा सर। जो टेबल में जो 5 क्लासेस उसकी दी हुई हैं, वो मैं 2-3 बार ट्राई किया, बट उसका प्रॉपरली उसकी जो विजुअलाइजेशन है जो इमेज की, वो वैसी आ नहीं रही जैसी उसमें एक्सरसाइज में देके रखी है।
आप उसको 5 ग्रुप में क्लासिफाई कर रहे हो ना?
जी सर, जी सर।
कितने ग्रुप
सबसे
में कर
पहले
रहे हो?
स्लोप है ना, स्लोप के लिए मैंने उसको ऐड किया, और जो डेम थी, डेम से फिर स्लोप में गया, स्लोप में फिर रिक्लासिफाइड रास्टर किया उसको, मतलब 5 क्लासेस में सिम्बलाइज किया। तो फिर उसकी जो वैल्यू जो दी हुई है, वो मतलब वैसे तो 0 to 9 आनी चाहिए, मगर मेरी 0 to 89 आ रही है। वहाँ पे मुझे कुछ कन्फ्यूजन हो रहा है, और जब मैं उसको फिर टेबल में जाके रिक्लासीफाई बाई टेबल में जाके उसकी जो इनपुट वगैरह मैं डाल रहा हूँ, तो फिर उसका जो कलर जो एक्चुअली में जो एक्सरसाइज की जो सैंपल वाली जो दी हुई है इमेज, वैसा नहीं आ रहा जैसा आना चाहिए। तो पता नहीं मुझसे
नहीं,
कहाँ
आप उसको नहीं, आपको उसमें वो जो स्लोप आया फाइनल आउटपुट,
जी
आपने डीएम से जो स्लोप किया उसको डिग्री में लेके गए, तो
जी
उसमें उसके कितने क्लासेस बनाए आपने?
उसका भी वही 0 मैंने क्लासेस
9
उसके
बनाए, 5?
उसके भी स्लोप के भी क्लासेस करने थे पहले ही।
नहीं,
सर
एक
उसमें
तो जब आप रिक्लासिफाई आपने किया ना उसको,
जी
तो उसमें आपने कितने क्लास में किया?
5 क्लास में सर।
5 क्लास में किया।
जी सर।
और मैनुअल में भी 5 ही था ना,
हाँ, मैनुअल में भी 5 ही है सर।
या 9 था?
नहीं, 5 है सर।
तो
5
जो आउटपुट आ रहा है, आपका कहना ये है कि जो मैनुअल में है उससे मैच नहीं कर रहा है?
मैच नहीं कर रहा सर। जी सर।
नहीं, लेकिन उससे कोई फर्क नहीं पड़ता है। मैनुअल में भी सेम मैप लिया होगा तो सेम दिखेगा। अ, हो सकता है मैप अलग हो, या जो क्लासेस का डिवाइडेशन है उसमें कुछ अलग होगा।
नहीं
उसमें
सर, सबसे
बेसिकली क्या है ना, आप देखिए, आपके पास मैप आ गया, उस मैप को
सबसे
आपने रिक्लासिफाई करना है बस।
नहीं, सबसे पहले सर, सबसे पहला स्टेप है जो डैम है ना, डैम को मतलब रास्टर में जाके उसको ऐड किया। रास्टर में जाने के बाद फिर उसको आ, उसकी जो क्या नाम है इसका, एनालिसिस में जाके इसको स्लोप में लेके गए। फिर स्लोप बन गई, स्लोप बनने के बाद फिर
ठीक है।
इसको रिक्लासिफाइड रास्टर किया, क्योंकि रिक्लासिफाइड रास्टर करके, नहीं सॉरी, रीप्रोजेक्टेड किया।
नहीं,
रीप्रोजेक्टेड करने के
उसमें
बाद उसकी
स्लोप को, हाँ, स्लोप को आपने डिग्री में कन्वर्ट किया था या एज इट
हाँ
इज
जी,
यूज किया?
जी जी सर, डिग्री में किया सर।
हाँ हाँ हाँ। और उसके बाद उसको आपने रिक्लासिफाई किया।
हाँ, रिक्लासिफाई किया। रिक्लासिफाई करने के बाद जो टेबल दिया, रिक्लासिफाई बाई टेबल, उसमें मैंने उसकी जो वैल्यू थी वो 5 टेबल में जो बताई गई थी मिनिमम टू मैक्सिमम, वो वाली मैंने ऐड की।
हम्म।
तो फिर लास्ट में जो
करेक्ट है।
रिक्लासिफाइड रास्टर लेयर ऑटोमेटिकली ऐड हो गया। आप इसको थोड़ा
हम्म।
देख देख सकते हैं, मतलब 1 मिनट में स्क्रीन शेयर करूँ तो जो
हाँ,
मेरी बनी हुई है वो सही है या गलत है, क्योंकि उसमें उसका जो मिनिमम
नहीं
जीरो
नहीं,
और
वो
मैक्स।
सही, नहीं नहीं, उसमें गलत होने का कुछ नहीं है। आपने उसको, जो भी आउटपुट आया उसको 5 क्लास में डिवाइड रिक्लासिफाई किया।
जी
हाँ, तो वो सही है। फिर 5 क्लास रिक्लासिफाई हो गया, यहाँ तक तो मुझे कोई गलत नहीं लग रहा है।
सर, 1 मिनट देख तो लीजिए, मैं स्क्रीन शेयर करता हूँ
हाँ,
क्या
लगा,
है।
शेयर कर सकते हो।
आप होस्ट है ना सर, तो मैं कर सकता हूँ ना।
एक मिनट, मैं आपको, मुझे वो करना पड़ेगा आपको, कमल स्टार्ट वीडियो बैक होस्ट। आप करिए।
ये देखिए सर,
हम्म।
ये रिक्लासिफाइड रास्टर मैंने ऑटोमेटिकली जो ऐड हुआ है रिक्लासिफिकेशन टेबल में जाने के बाद, तो ये इस तरह से दिख रहा है। आप मेरी स्क्रीन देख पा रहे हैं सर?
ब्रांड 9। एक मिनट, इसका इससे पहले वाला स्टेप का आप इसको ऑफ करिए, थोड़ी देर पहले वाला दिखाइए, लगाइए।
हाँ, इसके पिछले वाला जो है वो है स्लोप। ये बना था, ये सही था।
है ना, स्लो को मैं उसकी मिन मैक्स दे, इधर 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 लेफ्ट साइड, वो टेबल ऑफ कंटेंट में, टेबल ऑफ कंटेंट, हाँ, यहाँ पे करिए।
जीरो
डबल
टू
क्लिक
एट्टी
है
नाइन
इस, हाँ, इसको, हाँ। हाँ, तो ठीक है, 0 to 89 है, 0 to 89 है।
ओके।
इसमें ना, नहीं, आपका स्टेप में कोई गड़बड़ी नहीं दिख रही मुझे, क्योंकि जो इसमें रहेगा रिक्लासिफाई करके जो आएगा ना,
ओके,
रहे,
तो सर मैनुअल में तो
ये आपको
जीरो जीरो
वो
मिनिमम
करना है।
0 और मैक्सिमम 9 बता रहा था, तो यहाँ पे कुछ मैंने स्टेप तो सारे सेम वैसे फॉलो किए हैं, बट पता नहीं अब मुझे अब देखिए, मैं आपको 1 मिनट मैनुअल भी दिखा देता हूँ। मैनुअल में क्या दिख रहा है, कैसे दिख रहा है, तो वो भी मैं दिखा देता हूँ। मैनुअल वाली लास्ट में जो बन गई है वो ऐसी बनी है, ये देखिए सर, अगर आप देख पा रहे हैं तो ये मैनुअल में ये है
नहीं,
रिक्लासिफाइड
मैनुअल
रास्टर।
मैनुअल नहीं आया
ओके, 1 सेकेंड 1 सेकेंड। जी सर, अब देखिए सर, सर इसमें मिनिमम 0 और
करिए,
मैक्सिमम 9।
जूम करिए।
ये मैनुअल में दिया हुआ सर, 0 to 9 है। और ये रेड कलर, जो रेड कलर तक तो मेरा सही सही आ गया था। उसके बाद जब इसकी कलर शायद कलर कॉम्बिनेशन गलत हो सकता है थोड़ा बहुत, ये पता नहीं, मुझे नहीं पता।
नहीं 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 नहीं, इसमें ना इसको मैं आपको अभी मुझे अभी इसमें लग रहा है क्या हुआ होगा।
जी
आपका जो डीएम था ना,
जी।
डीएम में कुछ एम्प्टी सेल्स थे,
ओके,
उसको फिल किया था क्या आपने?
ये देखिए सर, मैं बता देता हूँ मैंने कौन सा वाला डीएम शेयर किया था। अगर आप देख सकते हैं तो एक मिनट रुकिए।
नहीं, उसमें कुछ जीरो वैल्यूज और वाइड वाइड स्पेस थे कुछ, बाकी सारे 0 to 9 पे हैं बाकी लेयर्स।
सर ये देखिए, सबसे पहले मैंने ये वाला, ये डेम है, इसमें 188 टू 1207 था, इस पे मैंने किया था, ये डैम है।
हाँ नहीं, इसी डाटा में कुछ सेल्स ऐसे थे कि जिसमें ये डाटा नहीं था।
ओके
हाँ तो शायद बाकी इस आपका एज इट इज रहने दीजिए, बाकी
ओके।
लेयर्स। इसी को एक बार डाटा जो गैप है ना, वो
हाँ हाँ,
फिलअप करके सिर्फ इसी लेयर को एक बार और बनाइए आप, उसको फिलअप करके।
इसी लेयर
क्योंकि
को।
वो जीरो टू 89 नहीं है, वो इधर किसी स्टेप में एरर है, या इधर जो आपने इसमें जो गैप थे जिसमें डाटा नहीं था उसकी वजह से ऑटोमेटिकली कुछ वैल्यू पकड़ा उसने, या जहाँ पे आपने
सर ये
9
वाली
प्लस।
सर ये वाली इमेज देखिए, ये वाली ये इस वाली पे स्लोप बनाना है या फिर अ, इस
नहीं
वाली
नहीं
पे
नहीं, आपको
ये-
आपको जो डीएम था ना,
हाँ हाँ।
उस देखिए क्या करना है, उस वो डीएम को लेना है। उस डीएम में से कुछ गैप्स थे जिसमें वैल्यू नहीं थे, वो वैल्यू डालनी है। उसके बाद आपको बाकी का चीजें करनी है इसको।
ओके, तो इसको इसमें इसमें कैसे कैसे करेंगे, तो फिर जैसे स्टेप्स दिए मैंने तो वैसे फॉलो किया था पहले।
हाँ, उसी स्टेप से इसको नहीं, आपने वो डाला था कि इसमें जो गैप थे वो फिलअप किए थे क्या?
नहीं
पहले
सर, वो
पैरा
मैंने
में दिए,
नहीं वो
पहले
नहीं
पैरा।
किए थे।
हाँ तो वो एक पॉसिबिलिटी ये है। दूसरी पॉसिबिलिटी ये है कि जहाँ पे आपने 9 क्लासेस सिलेक्ट किए थे,
हाँ हाँ।
वहाँ पे टाइपो मिस्टेक हुआ होगा, 9 के पहले 8 9 हो गया होगा। एक पॉसिबिलिटी है, दोनों में से एक होगा कोई ना कोई।
सर 8 9 तो मैंने नहीं किया, बट मैंने जो आप जो गैप वाली जो बात बता रहे हैं वो मैंने गैप नहीं डाले थे, तो वो मुझे पता नहीं था कि गैप मैंने डालने कहाँ पे है।
हाँ, वो शुरू के पहले पैरा में ही होगा ये। दिया है प्रोसीजर वहाँ पे कि कैसे उसको फिलअप करना है। ये करके देखिए, हो जाएगा। नहीं होता है तो आप मुझे फिर से कनेक्ट करिए, हम फिर इसको पूरा रन करते हैं ऑन
ओके ठीक है सर, ओके, थैंक
ऑनलाइन।
यू सर, थैंक यू।
ठीक है, अभी मैं भी 2 मिनट ब्रेक लेता हूँ और
जी जी सर,
आप।
जी जी, सॉरी सर।
नो 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 प्रॉब्लम। अगर ये आपका नहीं होता है ना, यू
जी
प्लीज मुझे पिंग करिए। ऑनलाइन हम इसको कनेक्ट करेंगे और इसको करते रन फिर से।
ठीक है
कहीं
सर,
कुछ।
ओके, थैंक यू सो
हाँ।
मच सर, थैंक्स अलॉट सर। waiting for the data to come through.
Is the class started? I cannot hear anything.
Shall we start now? Are you back?
Yes, sir.
Okay. So I have to share the screen. Screen is visible?
It's visible.
Okay, okay.
Yes, sir.
So now in the morning session we have seen the how to create the GIS data. Now and what are the issues, sources, quality, topology, etc. we have seen. Now in this session we'll see the analysis, output, then the designing, project, as well as spatial analysis. So this portion will cover here. So we'll see spatial analysis, then the designing part and the implementation, as well as output. So just quickly, what is your understanding about the spatial analysis? Just one word, one sentence.
Spatial analysis, we can go through this special or toolbox to find out the shortest distance from one point to another point.
Okay, so that means once you have data, you are using various tools and techniques, algorithms, okay, to get some additional information, some required information. So that is in general, like you have a road layer, you can put a buffer to get additional information based on road layer. Okay, so from the existing data, you will get additional information that is required. So that is very rough way of understanding the spatial analysis, and we are calling it as a spatial analysis. It works on the spatial data. So we use wide range of methods, right from simple to complicated, right from simple formulas to complicated statistical formulas. So there are various tools and techniques to use in a spatial analysis that act on your data, that operate on your data, and it will provide you certain useful information. So that is in general spatial analysis. Okay, so here in this map you can see one layer, uh, this green color, light green color layer, and uh, surrounding to that yellow color boundary we can see is output coming from the spatial analysis. Okay, maybe something like buffer. Okay, now can you enlist the spatial elements? Anyone? What are the spatial elements? I know you know the spatial elements, but the problem is different here. I know you know the answer, but I'm asking question in a different way. Can anyone tell me the special elements? Okay, so only thing, if I asked question in a different way, everyone might have tell me that, oh, it's a point line polygon. Or it is why are you asking this question? So simple question. Okay, so these are the special elements: so point, line, polygon, and surface. Okay. Now, one more question. What type of overlays? Overlay means putting two or more layers on top of each other and getting some information. Okay. So now you know the special elements, it's point, line, polygon, or surface. Okay. So what type of overlays are possible using these features? Yes, go ahead, Kamal.
Raster and vector, sir.
Types of overlays I'm asking. You don't have any raster and vector. You have point, line, polygon. What type of overlays are possible? Because you have only these elements with you. These elements will be used in the analysis, spatial analysis, and using the overlay technique. So what type of overlays are possible?
Land use, soil, river, water body.
No, Anamika, no. That you are going 2 steps ahead. Okay, I'm asking you. You have special elements. What special elements are there? It is point, line, polygon. Using these types of
You can have state and you can overlay roads and you can overlay any point location like temples or
no. Don't specify the layer name. I'm asking, your answer may be correct, but you are going 2 steps ahead. I am asking, you have point, you have line, you have polygon. So using these three, what type of overlays are possible? इसको समझना बहुत जरूरी है, क्योंकि वो एनालिसिस करने के लिए जो आप लॉजिक लगाएंगे वो उस पे बेस पे रहेगा.
Sir, point on point, point on polygon, polygon on polygon, like that.
Point on point, is it possible?
सर ओवरले तो फिर उसी जैसा मतलब हाँ मतलब जैसे पॉइंट इन पॉलीगन, लाइन इन पॉलीगन इन.
पॉइंट इन पॉइंट नहीं होगा.
हाँ सर वो
Point
मतलब वो
on
तो फिर एरर हो जाएगा ना उसमें.
point on line, line on polygon.
हाँ लाइन इन पॉलीगन.
Line you can overlay in polygon, and polygon you can overlay in polygon. Is there any other possibility that is possible apart from this?
point on line.
Polygon on polygon.
Polygon is there. Last
Polygon
option is
on
there.
The line in line is possible. Line in line.
No.
Point on line.
See, ultimately, no. It's not just overlaying one layer on top of other. That you can overlay any layer. But what information you will get? Because our purpose is to get the information. For example, if you overlay polygon on top of point, then you can count point in each polygon. You can count the line. You can count the line length. So further, you have to derive the information also, na? Okay. So in that sense, only these three possibilities are there. You can have point in polygon, line in polygon, or you can have polygon into polygon, or area into area, or area into polygon. Okay, both are the same. Okay, and now once you have the possibility of these type of overlays, so
Excuse me, sir. Why can't we
yes,
have point on line?
you can have, but what information you will derive from it?
Sir, we can derive like suppose we have gauges or we have dam or we have river point locations on a river, which is river center line. So we may want to know whether it's on the line or not.
If
Like the
it
river
is
gauge points are, or whether dams are on the river line or not. I do such kind of analysis.
no, oh, no. You for that we have different this one, but you ultimately see you have to measure, na? Like you have some layer, and so how you will measure? If you
Sir,
are
your
saying
voice is not.
dam, then it will come under the category of polygon.
No, sir.
And
Actually,
polygon
Point
line
location.
overlay is
Dam is a
possible.
no,
point
sir.
location.
It can happen, sir. Actually, for measurement purpose,
Gauges are point location.
we can the concept now I cleared. So suppose there is a polygon. So inside the polygon, how many points and line are there? Then it can be find out. But the
Exactly.
line and
You
point
have
also.
severs on. You have
Line and point also, sir.
sewer location on. Sewer network. Sewer network is always a line, and then you can
Yeah,
have
yeah.
a point on it, which is a manhole. So that
Yes,
is
sir. Yes, sir.
point on line.
Yeah, correct, sir. Correct, sir. We can find out, sir, the same way for line and point also. Even how many points are intersecting with the line, that can be measure, sir.
Okay. So you mean to say point in line?
Yes, sir.
Point in line. Is
Right,
it
sir.
possible?
Yes, sir.
I would say point on line.
Online possible, in line not possible.
Not in line, sir. On line, because suppose
That's why.
there is the road junction
No,
point, for example.
that's why I told in different sense we can measure. So that measurement will be the distance between point and the line. Okay, so it can be zero distance, it can be distance. That says it is possible. But if you want to measure points inside the line, that is not possible.
Yeah,
Right?
because point inside the lines
You
is
can
not an enclosed feature. That is what you mean.
yes, that is not possible. And if you put this in the analysis, the results will be mess. That's why
Yes,
only these
yes,
three
you're right.
conditions: point
Okay,
in
I got it.
polygon, line in polygon, and polygon in polygon. Okay, that's why I am putting
Correct,
this.
I got it.
I know if the conceptually we are not clear, then there is a possibility of
Yeah, no, I got your point
errors.
now. Yeah.
Yeah. So now ultimately we want to measure, no? We want data actually. So in case of points in polygon, you can count. You can count easily, na? If a certain bunch of points is encircled by a particular polygon, you can
Right.
easily count how many points are there in a particular polygon. In case of lines, what we can do, we can measure its length. Okay, we can measure its length. Now this length, line can be straight or it can be curvature also, curvilinear also, right? These two possibility in case of length are possible. And in case of the polygons, what is possibility of measurement? You can measure its area and you can measure its perimeter, because you have the arc or line length with you can measure perimeter. Correct? So these are the possibilities, and these are the basis. Whatever spatial analysis you do, whatever any software, only these are the possibilities. There is no other possibility. If we are taking any other possibility, then there are chances of having errors. Maybe some of the software will take your input also. Many softwares will not take, but I don't know. Some of the software, if it takes the inputs other than this possibility, there is a possibility of error. So only these are the feasible possibilities which you use in a measurements and spatial analysis. Okay, so this is the simplest spatial analysis, buffering. Buffering, sometimes it's called corridor or zone generation. So buffering is nothing but you have one feature. Surrounding that feature, you can create another feature. Okay, so that like you have point layer, so you can create a polygon around it based on certain distance. It will encircle the point and give a another feature. Right. So then you have line, you can get a feature buffering. Similarly, in case of the polygon also, you can get inside, outside buffer. Some softwares will provide single buffer. Some softwares will provide both side buffer. But please remember, output of buffer will be always polygon.
Now Muskan is the host.
सर का ना इंटरनेट का इशू है आई थिंक कुछ
जी ऐसा लग रहा है
उनका वीक, हाँ, बीच बीच में डिप कर जाता है वो अब फिर से होस्ट बनवाना पड़ेगा
होस्ट कैसे चेंज हो रहा है बाय डिफॉल्ट? कौन बन गया?
So I think whoever logs in first becomes automatically the host.
But it should not change automatically, na?
So then I think you need to have a co-host.
Anyway, hello, let us hope screen is yeah. So what I was saying, the output of buffer will never be a other than polygon feature. Correct? Agree सब लोग?
Agree sir.
So now let us understand this concept. It's simple, but many times creates confusion. Now union. See, these are the two layers A and B. You can say A unites with B. Now what happens if you run an operation? Both the layers A and B will be there with all attributes. Okay, in the output. In case of union. Now, using intersection for these two layers, A and B layers. Now, what happened? Only the portion where they interact or intersect with each other. Please try to understand the difference here. In union, you got everything. In intersection, you got only the portion where A and B overlaps with each other. Clear?
Yes sir.
So reclassification already you did. So and you are doing maybe for few of the exercise also. So in reclassification, what you used to do, For example, DM last time in last exercise you reclassify land use, you reclassify. So reclassification is basically generalization. You are reducing the feature, you are reducing the boundaries, you are making your data more generalized. For example, I am having say the district maps of whole country. So I want district map, I want just state boundaries. So what I will do, I will reclassify the map based on the states. So district boundaries will not be there, only state boundaries will be there. So that is the concept of reclassification. That is, you are reassigning the thematic values to the existing map. Okay, then query. So query we are using at many places. For example, if you ask me, where are you right now? Where are you? So I will provide you answer. I am in Pune. Okay. So oh, similar fashion, we used to ask question to the database through the software, HTML or some media. The data from the database is retrieved and the answer will be given, or the data will be displayed for us or made available to us. So we can ask the question to the database, where is it a particular feature, what is its location, what is its spatial relation with some other feature or with some other attribute. Even we can ask what is similar to a particular feature. For example, a feature is having value say 9, you can ask find out the other feature that the 29 used there. So basically it's a set of questions to get the specified information. Okay. Now this maybe one is special query which runs on special data, another is non-special which runs on your attributes, then the topological query and the spatio-temporal. These are the types of queries. So special queries can be your location-based query, distance-based query, then map element query, either vector, raster, then the area based queries. So these are the type of special queries which you run on the database and get the information. Okay, so this was simplest step. So I was on 5th gear. So any question on that? Okay, fine. Now we'll see raster. So raster analysis is, you can say it's a simple, once you understand the concept, it's just like algebra. Okay, it's a simple, basically manipulations in the data using certain formula and criteria. Okay, so in this raster analysis we'll see the 4 types. One is local function, focal function, zonal function and global function. Okay. Local function works on single cell. The next type, focal, it processes the data each cell again based on information specified in neighboring cell. Okay, we'll see detail, then you will appreciate this concept. Then zonal function use the concept of zone. Okay, it group the value in the zone based on certain criteria, and it identify the values in your input based on that zone. Okay, and the last one, global function, that work on cell based in the data of the entire. I am 100% sure you all are fully thoroughly confused with these 4, but believe me, it's very simple. Let us have look on the coming slides. So you will, yeah. First one is local. As I told, we have on cell. हर सेल पे ये काम करेगा. There will not be any effect of the surrounding or other cells on a cell which it is working. So individual cell is having its own way. So there will not be any impact of the external or neighboring cell. And it's single layer. See, it's a single layer operation also. So you can easily did many operations using the local grid analysis like addition, subtraction, multiplication, division, even more complicated also. These are the few examples I put here that you can use on using the local grid analysis. Now, let us play a quick game here. On okay, local grid analysis. So this is my input grid, okay, and this is my output grid, and I am damn sure you all have used this local grid analysis for some of your exercises or projects somewhere. I'm damn sure about, but only thing you might have. So let us get the output grid here. Can anyone tell me what will be the value here in the pointer where I kept the pointer? होने दो ना गलत. Tell, don't worry.
6.
Anamika is saying 6. Any other option? No option. सबको डर लग रहा है गलत हो गया तो क्या करेंगे. अब अनामिका ने 6 बोल दिया, अब सब लोग हंसेंगे, आंसर गलत आएगा तो अनामिका के ऊपर, है ना.
2 sir, 2.
Doesn't matter to me.
60 लग रहा है.
Kamal, you are saying 2.
Sir, 3.
Okay.
3.
3. Okay. Let again tell you the question. We got the options 6, 3, and 2. Okay. This is your grid. Okay. This is the fact which will act on each cell as definition. This factor will interact with each cell and you will get the output. So now the question I have asked is what is the value for the grid where I put the pointer. First option we got 6, second 3, and third 2. Anything else? Any other answer? So 3 learners came forward. They doesn't care that you laugh or what. Right? Any answer?
So 6.
Okay, 6 gosh. Okay. So 2 answers for 6 we got. Oh, we'll stop this game and we'll see what is the answer and why that answer is. Answer is 6. Okay. So as I told, this factor will act on each cell. So 2 into 3 will become 6. Now, I know why the answer 3 and 2 came. वो आने भी बहुत जरूरी थे, तभी तो हम समझते इसको. Or 2 answer came because of the confusion that I told there will not be any impact on the neighboring cells. Okay. That's why the 2 and 3 answers came. They thinking that, oh, no, there will not be any impact. It will be 2. So, because of some confusion, but 2 into 3 will be the 6 is the right answer here. 0 into 3 is a 0 right answer here. Okay. Similarly, This is the factor plus 5 and this is the input grid. So it will work accordingly. So now these values are right or wrong? Okay, these are the correct. Okay, 5, 2 plus 5, 7, 5 plus 0, 5, 5 plus 1, 6. You
No,
got
all are
this?
correct.
This is very simple. Only
This
thing
is simple arithmetic.
you
It is.
should, yes, but if you make any confusion in concept, then there is a problem. Otherwise, it's very simple. Now, again orient ourselves on the concept. Now, this is my input grid and this is my multiplier grid. Okay, I'm going to multiply. These are the two grids I am having, and here I want output. This is my output grid. Now, can you tell me what will be the value here where I put my
2.
pointer?
2.
Oh,
2
Anamika
into
is
1,
saying
2.
2.
Sir, 2.
Everyone says 2. Anything, any other than 2 answer?
2 sir, 2.
So I hope you understand. It's simple arithmetic calculation. Okay, so then for example, we have taken the simple examples, but you can use local maximum, local minimum, average, whatever you want. Okay, so any operator you can take and you can get the output grid. So and you have used, so you have converted like slope into degree or degree into slope or some mean standard deviations. So all this will work on a local grid basis. Okay, so and you can see some research paper. Even I have also published one research paper on local grid analysis using universal soil loss equation. So using this formula, 5 factors, 5 different layers. So these are the applications of local grid analysis. Very handy, and you can use for different purposes. Now, next category is focal. Again, we'll understand the concept of focus and we'll play the game so that will make our concept strong. Earlier we saw that local grid doesn't have any impact of neighboring cells basically, but यहाँ पे neighboring cells का impact होगा. So यहाँ पे we generally use the kernel 3 by 3 different type of kernels when you make the smoothing operations, edge detections, some rectifying the missing data, you use the smoothing operation. So there you use the focal grid operation. If you have corrected some missing lines in the data, satellite data, definitely you might have used the focal analysis. Whatever the name in a particular software, name can be anything, but the background, it should be focal grid analysis. So it used basically the kernels, 3 by 3 kernels, and it performed the focal grid analysis. Now, as I told, it works on values of neighboring cells. Remember, this is very important in focal grid analysis. So now I am putting a kernel. I told you it's a 3 by 3 kernel. So because of the border, you may not be seeing 3 by 3 kernel, but don't worry. So using this green blue color, I want output. I want output in the uh, grid where I put the pointer. What will be the output? Before that, please remember what we are doing. We are doing focal sum. This is our objective, focal sum. This is my input and here is my output grid, and this is my kernel. Blue color is my kernel. Now question is, what is the value for this grid where I put the pointer, which is in red color?
7.
7.
Me too, 7. 7.
7. ओके, सो 3 आंसर आ गया, तो अभी चौथे टेस्ट नहीं करना चाहिए आंसर। तो समझ लेते कि ये लोग 7 बोल रहे, तो 7 कैसे आया? आंसर इज 7. हाउ इट इज 7? Because
3
it's a
plus 2 plus
sum.
2.
Yeah, it's sum of what? What they did? Kernel. So they just added all the value. That is the focal sum. Okay. Now, what will be the value in the next grid? Here.
So my question here is, why are we summing up the 6 ones? Shouldn't it be a sum of 4 again, like 3010?
No. Yeah, you are right. But here we have defined 3 by 3 kernel.
So in the first instance, why didn't we take 3 by 3?
No, that's why I told it's a border.
No, it's a
That's
2
why
by
the
3,
kernel
right?
is small here. No, kernel cannot be 2 by 3. It can be 3 by 3. It can be 5 by 5. It should be equal. So just for example, because this is border, it's not ideally 3 by 3. It's less than that. Okay, so next. But this kernel, when you do actual analysis, you can define. What is the value here?
Sir, 8.
सर 5 होगा
This
सर,
is below 8.
सर
No,
5 होगा सर।
sum. Don't use the focal word. Focal is for focal cells, grids.
Sir, it is going to be
Okay,
8.
next kernel now. Yeah, it's 8. Now, what is the next yellow color?
9.
9.
9 and then 5.
Okay.
Sorry, 6.
6.
Okay, I think this is clear now.
Yes, sir.
Let me skip this. Otherwise, it will kill our time. Now, one more example. We'll do the focal mean. No, it's a focal average, not mean. So now let me put the grid. This is my grid. What will be the focal average for first grid?
And now it depends on whether it's an integer grid or the other one.
Whatever. I want focal
So
average.
we can
4,
so
4.
when it's average.
3.5.
4, 4.
Oh. 7 by 4.
Then it's going to be 7. That is why I said the answer will be in decimal. But if it's an integer grid, then it will not be decimal.
No, we're not going into that one. Just we trying to understand the concept. Whether it's an integer or that again. Anyway, software should also allow the type of data, raster data, that also should allow this. But just to understand the concept, this is my grid. Okay, so in this grid, 2 plus 2 plus 3, these are the values of each grid, and there are 4 grids. That's why divided by 4. This is simple average. So whatever is coming out of that, it will come here. 1.7, right? Now this is another. So what will be the value here at the pointer?
4 by 3.
Okay, so sum of this all divided
8
by
by
6, whatever is
4
coming
by
will go
3.
here, right?
4 by 3.
1.33 is correct.
Yes, sir.
Yes, sir.
Similarly, next kernel, you will do the same thing. You will take the sum and divide by the number of grids. So this is the focal average. Any doubt up to this in understanding the concept? Anyone? अरे बहुत मुश्किल है, डिफिकल्ट है, गलत है, किसी को लग रहा है ऐसे कुछ समझने में इश्यूज है तो बताओ. Okay, in the same fashion we can use the focal grid analysis. So with this concept you can have different type of analysis, mean, max, or any other analysis also, which you can put the formula. You have the focal grid analysis, and always you have to define the size of neighboring cell, how many cells you want to take into consideration. Based on that it will provide you the results, and that size will be common for whole layer or where whole data which you define. Okay, so you can use this to rectify your remote sensing data to detect the age. Okay, so even for terrain analysis also you can use slope and aspect. You can use this grid analysis. Okay, now moving to the next one, third category. First and second everyone is okay, I believe, no issue. Now third one is zonal grid. So it is using zone, and then it selects the value from the input grid. That means there should be one zonal grid and there should be one input grid here. So from the zonal grid it will select the values from the input grid, and then it will provide you the analysis. Okay, so two grids, two layers are must here. So let us see how it works. Okay, so this is my input grid and this is my zonal grid. Okay, and the objective here is I want zonal maximum. Okay, so now see the carefully, this is my zone. Okay, so based on this, can anyone tell me what will be the value here where I put the pointer?
2, sir.
2.
2.
5.
Any other answer?
6.
सर 2 इसमें तो मिनिमम मैक्सिमम एवरेज सब कुछ देना पड़ेगा ना.
6 sir. 6.
2, 5, 6. These are the answers.
आई थिंक इट्स 5.
थोड़ा सा कंफ्यूजन इसमें भी होगा कि जोनल मैक्सिमम में. So
yeah, zonal में max or zonal average, what are we giving or count?
3 also. Okay, so let us understand the zonal grid concept. So as I told, there will be minimum 2 layers. One is input, another is zonal grid. Okay, so this zonal grid, in the zonal grid will be used to select the zone in the input layer. So this is 2 is my zone here. Based on this zone I am going to select the grids in the input grid. So these 2 and this 1. So these 3 grids, 1, 2 and 5, and these 3, 2, 5, 5 and 3. So these are the cells. These are the cells grids which selected from the zonal grid. Now up to here is okay. You understood how we selected these two these grids here, the cells here, based on this?
Yes, sir. So wherever there was 2, we had selected all those grids from the input grid.
Exactly. Whenever there is a 2 is your zone. So whenever the 2 is coming, 2 means its respective place, don't confuse with the values in the input grid. Okay, so whenever there is a 2 in the zonal grid, respective cells were selected. Please switch on microphone.
झूलन आपका माइक्रोफोन स्विच ऑफ करो
Okay.
झूलन
So once we selected the zone, now look, what is the question? Zonal maximum. Zonal maximum मतलब इस zone में maximum value, zonal maximum, right? So that's why the answer is 4, and that 4,
5.
sorry, 5, right. Sorry. So that 5 will go to each cell where you have identified the zone. This is simple. Okay, clear?
Yes.
Now let me select the another one. Now I have selected this zone 3. Now tell me the
So
output
7.
here.
7.
Huh?
7.
7. Correct? Now this zone, green zone,
8.
perfect. 8, 8, 8. Okay, correct? Now I want to do the, now this is the concept. Only thing what is changing now, this is changing. Either it will be average, sum, maximum, minimum, whatever. So now quickly tell me the, for this zone, what will be the answer?
21.
किसने बोला? 6 कैसे बोला आपने? This is sum. We have to add everything. All the cells coming in the zone 2 we have to add, right? कोई confusion नहीं है ना?
No, sir.
Correct है ना 15?
Correct. Correct, sir.
Just make a sum of their zone grids coming under that zone. That's all. Now
Next
for
is
this
26.
zone,
26.
25, 25.
25, sorry.
Okay.
Okay.
So in this way you can use the zonal grid analysis. Okay. And there are many applications. I'll not go into it. Now coming to the last part, global grid analysis. Okay.
So this
so
zonal
let me tell
analysis, sir.
हाँ
This
बताइए.
zonal analysis, do we need to do manually or?
No, you nothing. You already using this. You have to do through the software. You are rectifying remote sensing data, maybe missing pixels, missing lines. So you are already using this.
Okay.
Last
Yes, we are.
exercise also. So this is the fourth one is a global grid analysis. So this is in the output raster, where the output value of each location may be function of, or we saw impact. Second, we saw the impact of neighboring cell. Third, in case of third, that is zonal, we saw the impact of zone. Consider zone created the output. Now here we are considering all the cells, and then we are getting the output. Okay, so the output value of each cell is a function of the all the other cells or the entire grid, you can say. Right? So
Yes, because of somebody else's mic is on, hearing anything.
let me mute someone's mic is on.
आपके एंड से आप वो झूलन का जो माइक है वो बंद कर दीजिए।
I have switched off all the microphones for time being. You can switch on later on if required. Okay. Now you might have heard the equilibrium distance, crow fly distance, straight line distance. So using this global grid analysis, in global grid analysis, we use that concept of equilibrium. So it's a distance from each cell to the its nearest sewer cells or to its sewer cells. You can even say the starting cell. Okay. Now it will be difficult here. Still, I will read the last point. It will be clear in the slide. So just I will read and leave it here. All adjacent cell line are geometry nearby adjacent cell okay, that we'll see in the next 1.1. Okay. To the next one. As we see, there are two distance. One is physical and another is equidistant distance. Okay. So in case of one, I told there will be one, and in case there will be 1.41. Okay. Now, in case of physical, the value we have given 1. Why we have given 1? That is half is from here, half is coming from here. Center of one cell to center of another cell. We have given 1 value. Okay. Now, why it is 1.44 in case of the diagonal or straight line distance? Because of this. So under 2 is 0.44. Straight distance, it's a रहेगा तो आपको ये है कि एक सेल से सेंटर से दूसरे सेल के सेंटर तक अगर आप सीधा लाइन
Sir, we
करते
can't hear you clearly. No, nothing. I'm not able to understand anything. Your voice is not clear.
okay. Or not. आवाज can you confirm? Can anyone confirm quickly?
सर अभी ठीक है.
But now you're audible.
Huh? Not audible. What about
Now
others?
you're audible.
Audible. Okay. So what I was saying, if you are moving from same cell, so it's a one. If you are moving in
Sir, voice is not clear, cutting. Some network problem, I think so.
now with this concept, let us see here. This is going to say automatically how it is changing host, I don't know. Now which host? No.
Hey. Look.
फिर नेटवर्क इशू लग रहा है, या तो डेटा 2 GB खत्म हो गया होगा.
You are the host now. Okay, thank you. So yeah, so let me put in presentation mode. Yeah, so half 0.5 from here, 0.5 from here can become 1. Okay, total physical distance will be 1. Great. From here to here it should be 1, right? Are you convinced yourself or not? So anyway, when I move in this way from center of one cell to another cell or grid, it will be always 1. So the distance will be 1 for each. Up to here it is clear? Anyone is having any doubt?
सर रिपीट कर दीजिए.
See, here in this blue cell, center of this cell up to, you can say, the starting of the next cell, it's a half. Similarly, from another cell, from here to here, it's half. So half plus half, it will become 1, right? So in the same fashion, center from this cell to up to this cell, it's 1. Okay. So same as like length of or width of one cell, it's 1. So distance from center of one cell to next cell is 1. Okay. So now coming to the next, if you are moving from this center in this fashion up to the next cell center, so it, how much it is the distance as we see in the last slide? 1.4. How? Point, it measures 0.7 here and 0.7 here, so it will be 1.4. Okay. Now with this concept, if you measure the distance like this, so it, how much it will be? 0.7, right? And for next cell it will be 0.7, so 1.4. Clear? तो ग्लोबल ग्रिड एनालिसिस में ये दो डिस्टेंस आपको याद रखना है, 1 and 1.4, or you can remember 0.5 and 0.7. That's it. Correct? So in this fashion, all this distance, it will be 1.4, 1.4, 1.4. So 1.4, 1.4, 1.4, and number of cells. If it is 10 cells, 1.4 into 10, that will be your distance. Right? So all your Google Maps and all, they are calculating distance based on this concept. Clear 1 and 1.4, any doubt?
No, sir.
No. Okay, fine. So in this way, you can calculate the distance, like from this cell up to this cell, it is 2. Okay. Similarly, from here to here, it is 2. Okay. Now the last one, so that I just want to confirm you understood properly. This is my source cell, and you quickly tell me what is the distance here.
1.
Perfect.
1.
Because you are moving 1 minute, half plus half. Okay. Now next, what is the distance here? Here, green line.
Two. 2.1.
See, let us understand this. This one is correct. You came here 1. From here you moved in this way. So this will be 1.4. This distance, red arrow. So 1 plus 1.4 is 2.4. Correct? Okay. This we have already discussed. Clear this equilibrium distance, physical distance. Okay. Any doubt? Local,
No, sir. Clear.
फोकल, जोनल एंड ग्लोबल. ग्लोबल में आपके ये दो डिस्टेंस याद रखना है. लोकल में ईच सिंगल सेल पे जो भी ऑपरेशन होगा उसका होगा, बाकी इसका इम्पैक्ट उस पर नहीं है. फोकल में नेबरिंग सेल जो आप डिफाइन करेंगे, कर्नल 3x3 5x5 व्हाट एवर यू वांट, उनका जो होगा, उनकी वैल्यूज उस पर्टिकुलर ग्रिड्स की, उसका एनालिसिस होके आपको जो भी होगा, एवरेज होगा, सम होगा, मल्टीप्लिकेशन होगा, व्हाट एवर यू स्पेसिफाई, उससे आउटपुट ग्रिड बनेगा. जोनल ग्रिड में आप जोन सिलेक्ट करेंगे, उस जोन के सारे वैल्यूज इनपुट ग्रिड के वो सारे सेल्स पे एनालिसिस होगा और आपको आउटपुट मिलेगा. एंड ग्लोबल में यू हैव कंसेप्ट ऑफ द डिस्टेंस, बेस्ड ऑन दैट ग्लोबल ग्रिड विल वर्क. ओके.
सर वो फिजिकल डिस्टेंस वाला एक बार रिपीट कर दिया सर, वो समझ नहीं आया थोड़ा सा. फिजिकल और
इसको और भी पीछे आने दो मुझे, और भी पीछे, यहीं पे हम इसको समझ लेंगे और एक बार. अभी और कुछ मत देखिए, ठीक है. जस्ट कॉन्सेंट्रेट हियर. ये मेरा एक सेल है, ये मेरा अनदर सेल है डाटा में, राष्ट्र डेटा में. ठीक है. अगर इसको मैं इससे यहां से मैं यहां तक आता हूं, हाफ है 0.5. ठीक है. फिर मैंने और ट्रेवल किया, ये नेक्स्ट ग्रिड है मेरा, इसके मैं सेंटर तक आया, तो ये भी मेरा 0.5 डिस्टेंस है. ठीक है.
यस सर.
तो इस वे में जो भी मूवमेंट होगा आपका रोड का, अगर आप लेंथ मेजर करना चाहते हो तो इस वे में अगर आएगा तो ये 0.5 प्लस 0.5 1 आएगा. करेक्ट. सो टोटल फिजिकल डिस्टेंस विल बी 1. तो बहुत, अगर मैं थोड़ा सा क्रूड वे में बोलता हूं तो ईच ग्रेड का एक डिस्टेंस है. ठीक है. बट मूव करेंगे तो आप सेंटर से करेंगे, इस सेंटर से यहां तक, तो वो भी एक ही आएगा. तो ईच ग्रेड का फिजिकल डिस्टेंस इज ऑलवेज 1. ये रहे फिजिकल डिस्टेंस.
जी सर. 1 हो गया.
1 होगा ये. उसके बाद जो ये इसी बेसिस पे ये सारे कैलकुलेट होंगे, ये सारे 1 1 1 आएंगे. नाउ another, we are talking about if you are moving like this equidistant distance, so इसका जो है ये 0.7 है, अनदर ग्रिड का 0.7 है. तो ये 0.7 प्लस 0.7 मिलके आपका हो जाएगा 1.4. तो दिस वे 1 and 1.4 इज कमिंग. ये क्लियर हुआ?
जी सर. जी सर.
ठीक है. अब इफ यू आर मेजरिंग फिजिकल डिस्टेंस, सो इट विल बी 1 1 1, जितने ग्रिड होंगे इनटू 1, दैट इज योर फिजिकल डिस्टेंस. और जो ग्रिड का साइज होगा, जैसे 10 मीटर का है, तो यू नो द ग्रिड साइज, यू नो द नंबर ऑफ ग्रिड्स, तो अकॉर्डिंगली वो डिस्टेंस कैलकुलेट होगा. अगर आप इक्विलिब्रियम में जाते हैं ऐसे, दिस वे, जिसका कि 0.7 प्लस 0.7 होगा, तो जितने ग्रिड होंगे 1.4 1.4 से मल्टीप्लाई होगा. ठीक है.
यस सर.
सो एनी अदर डाउट? So I will stop sharing my screen and will stop here.
सर स्लोप स्लोप वाला मेरा नहीं हुआ, वो मैंने दोबारा किया था। हेलो सर।
हाँ हाँ बताइए।
सर वो स्लोप वाला मैंने दोबारा ट्राई किया था, मगर वैसा ही आ रहा है, पता नहीं कहाँ पे गलती हो रही है। 0 to 89 ही शो कर रहा है, वो 0 to 9 नहीं आ रहा है।
Okay, maybe I'll connect you. We'll do it. आपके पास मेरा ईमेल कुछ है?
नहीं है सर।
Just you know my number?
सर you are in PG DGI group, are you there?
Yes, I'm there now.
Okay sir, okay, then I will ping you sir.
हाँ, maybe not today. आज I will be leaving for some other place, but
Okay sir.
maybe tomorrow we'll discuss. No problem,
Okay
and
sir.
we'll resolve it.
Okay sir, okay, thank you sir. Thank you sir.
Just a minute, just a minute. Yeah. And
Sir, your last 3 digit 020 mobile number.
8800436795.
9.
Is the class over, sir?
Yes. Thank you very much. Just I am copying this one.
Thank you, sir.
Thank you,
Welcome.
sir. Have a nice day.
Sir, can we drop off? Sir, can we drop off?
Just wait for a second.
Sir, 8800436795.
Yes. Yeah. Thank you, everyone. You can log off now.
Sir, I have texted you. Please.
Yes. I'll connect definitely, and we'll see.
Okay, tomorrow we'll connect, sir. No problem, sir. Thank you,
Okay.
sir. Okay, thanks a lot, sir.
Yes. Do you have any class?